非常感谢各位参加《大脑、心灵与世界：脑科学哲学的前沿研究与人工智慧及新冠肺炎的延伸应用》工作坊。首先有请今天的主持人，中央研究院中国文哲研究所黄冠敏研究员为今天的活动开场，掌声欢迎黄老师。
在座的各位学界朋友，大家好。今天非常高兴来主持这一场工作坊哦。那这个工作坊是科技部人社中心所办的一个会议哦。那延续前年以 AI 为主题，然后去年是气候变迁，那今年主要是脑科学的研究哦。那因应今年比较特殊的这个COVID-19 的疫情的蔓延哦，那这个脑科学研究也相应的要回应这个跟人工智慧以及新冠肺炎的问题哈。那今天也非常特别，我们请到这个Nordhoff 教授呢来为我们做一场专题演讲哦。那但是在这个演讲之前，我们会请那个清大的陈思婷教授来为我们做一个前导的介绍。好，那陈思婷教授呢是清华大学哲学研究所的所长哦，他是这个英国伦敦政治经济学院的博士哦。那他主要的专长呢是跟这个研究原因哈，这个因果，然后经济学方法论哦，然后实作哲学哦，科学哲学。那他对于这个跟Nordhoff 教授的合作呢，其实是有长久的经验哦，所以今天由他来做这一场这个前导的介绍呢，是非常适合哦。那我不多占用时间哦，那我就把时间交给这个陈思婷教授。
好，各位来宾大家好。那我今天的话就用很简短的方式就介绍一下 Nordhoff 的这个教授的关于时空的所谓神经科学和时空的这个脑科学哦。那个 Nordhoff 教授他主要的这个想法大概是这样啊，他就是说他认为说我们用我们的这个感觉器官去觉知外在世界刺激的话，那这个有关这个感觉的这个每一个刺激的话，它透过这个神经网络的运作，然后它会转换成所谓神经活动，然后那这些神经活动就会产生特定，有关这些刺激的特定经验，这样，那也就是我们有关这些刺激的特定的这个意识经验哦。那我们问题就是这样哦，就是说，那神经活动跟它的意识之间似乎有着1对1的这种关系。那假如我们认为是这样的话，那这个就是所谓的这个化约的神经科学的这个进入哦，那也就是所谓的意识的神经的这个联动模型 （Neural Correlate Model of Consciousness）， 那我们叫 NCC 的这个进入哦。那根据这个模型的话，特定神经活动是它是被视为足以产生一项特定意识经验的这个充分条件。那这个是 Nordhoff 教授他认为这个大脑的这个外在观点。好，那好，麻烦你按对这个对。那换言之，就是我们假如把意识视为是神经活动所单独激发的话，那神经预制的这个模型就会把脑的这个神经活动哦，那这个脑的神经活动可能是来自于自然环境，那就视为一项必要但不充分的预制啊，就是 predispositions。那当它跟其他外部的环境，也就是社会文化或者是身体的刺激相结合的时候啊，就是这个 stimulus 这个 induced， 然后跟其他的这些刺激，他们就可以共同充分的这个产生意识。好，那大脑之所以这么重要，它主要的这个原因，就 Nordhoff 教授来讲的话，它是可以利用它的这个 neural predisposition 的话，把2种形式的神经活动啊，一个就是所谓的刚刚讲的，就是刺激所引起的这个神经活动，跟自发性的 spontaneous 的这种神经活动呢，以一种方式把它连接起来，然后产生它的意识经验。那这个是Nordhoff 教授他所认为的大脑的这个内在观点哦。那再下一页，谢谢。 他在他的2015年的这个书里面的话，就有一个图哦，就是这个上面这个的话就是这个外部观点，好，那这个大脑完全对外在的这个刺激没有发言权，那下面呢是大脑的这个内在观点，那大脑的话对外在世界的这个刺激的话，它是有发言权。下一页，谢谢。那他是怎么样来做这个事情的？大脑那 Noto 教授他有提到，就是说他是利用这个所谓以差异为据的哦，就是 difference-based 这种编码的策略来认识外在世界哦。那就是当大脑在回应外在世界特定刺激的时候，大脑内的这个神经活动，它并不是单独这个来自于这个刺激而已哦。大脑的这个内的这个神经活动，同时对真正输入哦与这个预测输入进行了比较，也就是它会自己先做一个预测，那它所谓 predictive input， 然后真正接受外在世界刺激，这个叫 actual input， 然后它会做一个比较。那换句话讲，就是大脑它本身由于它这个 neural predisposition 的这种作用哦，那就会对刺激产生输入，那就会这个输入产生预期或者是期待哦，那这个就是所谓的 predictive input， 然后这项期待会跟真正的输入就是 actual input 进行比较，那它们之间的这种差异的话，就是所谓的 predictive error， 就是预测的这个错误。那刚刚所进行的这些活动，其实就是我们所观察到的所谓刺激所引起的这个神经活动。谢谢。那很明显的啊，就是以差异为据的这个编码就显示了这个来自于外在世界的这个真正的刺激哦，它不再是这个刺激所引起的神经活动产生的充分条件。好，那真正的刺激在这边的话，它只是一项必要但是非充分的条件。那它必须要与这个预测的输入结合，就是 predictive input 结合，然后以便共同产生所谓的这个刺激所引起的这个神经活动。谢谢。好，那大脑它是如何具体来处理这些刺激呢？刚刚所谓的这种 difference-based 的这种 coding strategy 的话是，它这种一种后设的这个描述啦。不过具体来讲的话，这个大脑它基本上哦，它在进行编码的时候，它不针对单独的刺激进行编码，那它是针对刺激所横跨的物理时间的不同的这种 discrete points 啊，所谓离散点的话，也就是有关这项刺激的这种frequency 的 distribution， 有关这项刺激的次数分布进行编码。他要举例说，譬如鸟在吟唱的时候的这种声调哦，那其实它所编码的是这种所谓的有关刺激的这种次数分布。那因为这个面向编码行为的缘故哦，那这个 Noto 教授认为大脑就形成了他自己所谓的大脑的这个时间结构啊，就是所谓的这种 temporal structure of the brain 这样。谢谢。那同时哦，大脑也对它相对于其他刺激的这个空间位置哦，然后进行编码。譬如说，大脑它可能可以针对这个小鸟的这个声调这项听觉刺激哦，然后相对于其他的刺激，譬如说，这个小鸟可能在树上，然后有所谓树上的树叶的这种视觉刺激，就这里的话就有所谓听觉的小鸟声调的听觉刺激跟树叶上面的这种树上的这种树叶的这种视觉刺激的空间位置，然后它会进行编码。那这个面向的这个编码，就会让大脑形成所谓它自己的这个大脑的这个空间的结构，也就是 spatial structures 跟 of the brain 这样。谢谢。那所以总而言之的话，被编进这个神经活动的这个讯息啊，就其实的话，其实就是应该是这个神经活动相关的这个刺激所横跨的物理时空之下的这种不同的离散点的统计次数的这种分布的讯息啦，所以它是一种，所以基本上面的话，这个我们刚刚前面讲 difference-based 的这种 coding strategy 的话，它是以统计为据的这种编码过程。好，下一张，谢谢。那大脑时空结构的这个经验的这个证据的话，那 大概可以根据就是大脑这个功能性的这种磁振造影图像显示，在不同的这个脑区可能会处理不同有关时间与空间的这个讯息。那藉由这样的讯息，我们可能就可以侦测与推论出来大脑时间，就是大脑的这种时间的这种阶层结构与这个空间的这种阶层结构 hierarchical 的这种 structure 的时候，这个 space 跟 time 这样。那这个各个不同持续时间或各个不同的时间尺度的刺激呢，那它会在不同的脑区启动这种编码的这个程序，然后并进而产生回应，从而形成不同的所谓的时间的接受窗口time receptive 的这种 windows 这样，并因此建构了时间的这种阶层结构。所以所以这样来看的话，就是大脑内部的这个空间分布它的这个阶层结构，它基本上是类似于像社会组织里边的这种核心跟边缘的空间分布的这种概念那我们只要把每一个单位的这个神经元视为每一个单个的神经元视为是一个这个单位的话，那在所谓预设模式网络DMN 之下的话，也就是所谓皮质中线结构，在这个区域所分布的这个神经元就属于这个核心地带的成员。那非属于核心地带的这个神经元，它就被归类为这个边缘地带的这个成员那神经元之间的关系，就这样的这种空间分布的话，就可以分成这种核心神经元跟核心神经元之间的关系 core 的这种 relation 或者是核心跟这种边缘的神经元的关系 core 跟 periphery 的这种关系，或者是 periphery 跟这个 periphery 就是边缘跟边缘的之间的这种关系。好，所以大脑内部的这个时空的这个阶层结构，跟这个外部世界的这些结构，两者之间的话，那它就会以一种，也就是大脑内部就是我每个个体这个人的这种那大脑内部的话，它有它的这种所谓的 spatial temporal 的这种 structure。然后，那外部世界也有它的 spatial temporal 的这种 structures。那它们两者之间的话，那就会以一种所谓自我相似的这个方式，形成了它们之间类似这个 Nossel 教授很喜欢讲的就是像俄罗斯娃娃那样，就是由内而外或者是由外而内的话，会有一种同构的这种包覆的这种关系结构，就是从内而外或由外而内这样。好，那所以只要根据前面的这些说法的话，那我们看一下大脑怎么样跟外在世界进行互动那大脑这个时空结构，就是我们每个个人这个大脑，那它就可以借由外在世界的刺激，那以一种方式回应或呼应外在世界的这种空间、这种时空结构。那大脑的这个时空结构，但是问题就是大脑的这个时空结构总不是那么相合于外在世界的这个时空结构，所以那个大脑可能就可以借由所谓的 temporal spatial 的 dynamics， 所谓的时空的这种动力学，然后的作用，然后大脑随时机动的可以针对外在世界的这种时空结构进行所谓的 temporal spatial 的 alignment， 就是所谓的时空的这种调整。那大脑的这种时空的动力学，那它是什么一回事呢？那他在给我们的这个文章里面的话有谈到，其实这个时空动力学的这种调整、这种 alignment， 它实际上是遵循一种所谓自由free energy principle 啦，就是自由能的这个原理来进行。那时空的这个动力学的这个调整的话，大概是这样就是说，大脑它可能可以透过感知，然后借由这种连续修正的方式，以来这种最小化大脑的这个预测或预设跟这个感知之间差异所具的这种 free energy， 然后透过这种方式的话，然后这个针对变动中的差异所引起的变动的这种自由能 variation 的这种 free energy 的话，那会产生，那就会对这个 free energy 的话会产生梯度下降的这种效果然后根据这样的话，那大脑内部的这个状态的话，那最终就会从世界的外部状态之中获得最大的资讯， 因而这个大脑可以最大化对于外部环境状态的了解。也基本上的话，他所要讲到就是说，大脑借由这种free energy principle 的这个作用哦，然后它可以最小化它这个预设跟感知之间的这种差异，但是它在另一方面，它可以最大化这个有关外部世界的这种资讯啊。所以这个动力学所谓的时空动力学调整大概是这样子啊。那接下来就是说，从以上的这种说明，那看来大脑有它自己的这种时空结构啊。那这个时空结构会针对大脑所处的环境之时空结构进行调整、适应，或者是趋同。所以我们可以说，只要大脑可以调整或适应它自身的内部的这种时空结构，跟大脑所处的环境相应的这个时空结构之间的差异的话，那么这个大脑的话，就可以在任何复杂的环境之下都维持它正常的运作功能。好，谢谢。所以大脑这个究竟如何认识外在世界？那大脑就是根据我们之前所提到这个内容哦，我们似乎就可以讲说，大脑借由这个试着将它的自身跟时空结构进行调整、适应，然后趋同大脑所处的这个世界的这个时空结构，那以便来认识这个世界啊。那下面的话，大概等一下 Noto 教授应该会详细的讲述了，就是说借由它这个时空。就这种伽马科学或神经科学的话，它怎么样如何关联于新冠肺炎？那粗略的讲，大概就是这样，就是说他认为就是其实在我们大脑的这个底层的话，那大脑的这个底层的话，有所谓的这种譬如说一种对于自我不同的这种认识哦，譬如说我们这个自己跟其他人的这种关系哦，然后在每个人的这个脑子里面可能有所谓的 self network 跟所谓的 other network， 那就看这个 self 的这个 network 跟 other network 之间的话，是不是有所谓的重叠？那以他来讲的话，他认为就是说东方比较亚洲的这种国家的这个人的话，经由他的一些心理学的这个测验的话，或脑科学的一些测验的话。他认为 self network 跟 other network 的话，它是重叠度是很大的，从而就会那在外国的话，这个 self network 跟 other network 的话就不那么重叠。那所以相对应的就是我们就会有比较interdependence 之间比较注重 interdependence 这种关系。那在国外的话，就外国西方国家的话，它是比较注重 independent 这种关系这样。好，所以从而就表现在。就是我们在西方国家跟东方国家在回应新冠肺炎上面的话，就会有不同的这种态度啊，就会不同态度。好，那第二个的话是它有关这个它跟 AI 之间的这种关系哦。那基本上他是这样认为，就是他说其实 AI 的这种发展的话，其实不是替代人类的这种智能，它是要去增强人类的这个智能。那借由这个我们这个图我们可以看到，就譬如说有一个人，他跟外在世界的这个沟通有问题啊，也就是他的这种脑内的这种时空结构，跟譬如说那一堆人的那种脑的时空结构的话不一样。那他认为说，AI 的这种建造的话，其实就是我们可能要建造一个 AI 当做一个 interface， 然后呢，它可以增强。刚刚那个被孤立的这个人，他之所以孤立，就是因为他在大脑的功能，在适应外在世界的这种时空结构上面的话，然后有不完全的地方。那 AI 的这种发展的话，应该就发展一种界面，然后让这个人他借由这个界面的话，他的这个自己内在的这个大脑里面的这种内在的这种时空调整的这种机构的话，可以去呼应到外在世界这种环境的这种变迁，这样，所以这个的话大概是这个 Noto 这个时空的这个神经科学的话，针对这个新冠肺炎跟这个 AI 的一种应用，这样，谢谢。
非常谢谢陈教授的 引言哦，那为我们做一个暖身哦。那因为我们接下来是这个主题演讲哦，那我因为那个 Noto 教授的关系，我就切换到英文哦。然后thank you for the presentation of Professor Chen, and we will switch to the session of keynote speech. But before the speech, I will first present three discussants. First, Professor Xie Renjun 教授 Professor Xie. And then second one is also Professor Xie Borang from National Taiwan University. Yeah. And the third one is Professor Wang Hua from National Zhengzhou University. Yeah. So I'm very glad to present Professor Georg Notov from University of Ottawa, Institute of Mental Health Research. His speech is about the dynamic brain, as Professor Chen has presented just a minute ago. Why spatial-temporal neuroscience is relevant for AI and COVID-19. And now, please, Professor Notov, please go forward, go to your speech. Yeah.
Yeah, thank you very much. Welcome. I see you many without mask. I'm very happy to see that. So thank you very much for inviting, and you presented me with quite a challenging combination of topics. So I hope I can justify and I can give credit to that. So let me share my video. I hope you can see that. Oops, where is it now? Just a second. Okay, perfect. Yeah, thank you very much. And as I said, you presented me with quite a challenge for the topics. And I hope I will cover some ground and give you some ideas. And Professor Chen already gave a very good introduction as far as I could understand. And I think really the basic idea of my talk is really how can we approach brain and mind? So what kind of methodological strategy we need to have in order to find that connection. And you see already the lower part here, this is really a tale for me about how hidden philosophical presuppositions, most often tacit, implicit, shape our model of brain-mind and how it can, as I would say, block neuroscience and philosophy. And what I want to present you here is sort of an alternative approach. But of course, every alternative approach makes have to have a starting point from the current approach. And what you see is really, very briefly, goes back, of course, to philosophy. And you know, in Western philosophy, every brain-mind always goes back to Descartes. So it's really okay. Descartes said, okay, the body is non-special. Everybody can observe it from the outside. And it's spatially extended. However, the mind cannot be observed from the outside and is not spatially extended. So, and for that reason, he assumed that the mind is special when compared to the body that is non-special. And I call this, if you want to put a philosophical spin on it, it's an argument of specialness. And I think that that specialness has been taken over from philosophy to neuroscience nowadays. So you have neuronal mechanisms which are non-special, not related to mental features. But then there are assumed neuromental mechanisms which are assumed to be special and, for instance, to be related to sense of self, consciousness, or mental features. And much of, particularly in the last 20, 30 years of neuroscience, try to figure out these special neural mechanisms, which are sort of an add-on on the otherwise non-special neuronal mechanism. So in a way, though we say now it's all the brain and no longer the mind, the basic features of the mind / specialness has been carried over from mind to brain. You see it here in my arrow. So, and if you want to specify that a little bit more, in current philosophy, particularly analytic philosophy of mind, but also phenomenology, you see this special non-specialness. The special side is sort of divided into reflective consciousness, phenomenal consciousness. In psychology, Ned Block, you all know access versus phenomenal consciousness, and of course down here is non-conscious. And in special neuroscience these days, you have special, let's say, for theories. In consciousness, special theories of consciousness here. On the reflective side, sort of more the global neuronal workspace theory, higher order thought theory, recurrent processing theories. Of course, and their classification as reflective might be debated, everything among the, and then you have probably more theories which claim to be more for phenomenal consciousness, like the integrated information theory, embodied theory. And down here, and Xi-Ting already mentioned it, you have basically a general theory of brain. For instance, Carl Friston, predictive coding, free energy, and I will come back to that at the end of my talk when I refer to AI. So you see an interesting, a basic hidden assumption from philosophy has really been carried over into neuroscience. And that means, and that's what you see in current neuroscience, we have special, different neuronal mechanism underlying consciousness as those from unconsciousness or non-consciousness. Yeah? And because they're different, if they were not different, one would assume they could not account for consciousness. Yeah? So it's really the difference which is key. And that has strong reverberations. I indicated it briefly for neuroscience. Here, for instance, for philosophy, if you were not assuming that the mind is special, so it's pure conceivability now, then we wouldn't come up with the idea of even raising the question, how is the mind related to the body and the brain? Because if the mind is no longer special, then the question for the relation cannot even be conceived. Yeah? So then the mind-body problem or mind-brain problem would be nonsensical, because it would be raising a question where there is no difference, no specialness. Yeah? Raising the question for a relation where there is no difference, then the question for the relation is nonsensical. Yeah? But I don't want to go into that, because that's philosophical territory. I leave that out. You see it also in the current theories of consciousness. We published, together with Victor Langer, I published this year this paper about different theories of consciousness. And trust me, writing this paper was a nightmare, because it's a jungle, it's a mess of everybody has his own approaches. But what unifies all these approaches is that they all claim to have a special neuronal mechanism for consciousness, as distinguished from all the other neuronal mechanisms. Like integrated information in the case of the IIT is distinguished from non-integrated information, that is non-consciousness. Globalization of information is special for consciousness, as distinguished from local information processing, as claimed for in the global neuronal workspace. And you name it, higher order thought is special for consciousness, meta-representation as distinguished from non-meta representation for non-conscious. And you can go on and go on. So it's always a special mechanism, an add-on. And what we are trying to do in this paper is we discuss these different theories, give an overview, and ultimately what we say, look, embedding and integrating these supposedly special neuronal mechanisms within the broader framework of the non-special basic neuronal features of the brain. So basically we try to overcome this specialness and say, look, we integrate that. Whether we succeed, you can read and give me feedback and say, not of you failed. So this is the key hidden assumption in much of current analytic philosophy of mind, and also in current neuroscience. I say, maybe try out a different approach. Look into nature, maybe we look for the similarity. What do these neuronal mechanisms, underlying consciousness, sense of self, free will, agency, emotion and feeling, and all kinds of mental features, share with the non-mental the neuronal features underlying the non-mental. Yeah? So, and that is really this is really the basic question. So when you look for similarity, I think I did a mistake here, sorry. So then you don't no longer look for what is different, but then you look for what is shared. Shared between the neuronal mechanism underlying non-consciousness and consciousness, and ultimately also, let's say, between the neuronal side and the phenomenal side. So in that raises is like a common currency. How can they communicate? So that's why I introduced this concept of common currency in 2 papers this year. So it's like a common language. So I speak English, you understand English, so we can understand and we can interact. So and that's basically really the idea. I look for what is shared between these 2 kind of neuronal mechanism, mental, non-mental, as well as between neuronal and the mental. And that is really behind the idea, and that really is driving the current approach. That's why I said the hidden assumption, I changed the hidden assumption from difference between mental and non-mental to similarity / shared / common currency between the mental and the non-mental. Yeah? And I will show you that approach, and I hope it makes sense because it really, at least to my taste, yields novel insights. So, then of course you say, yeah, Nordhoff, yeah, what is now the shared similarity, the common currency between brain and mind, between neuronal and neuromental mechanism? And that's where I refer to what I call temporal spatial dynamics. And I think Professor Chen already indicated some of that. It's not discrete points in time, it's the relation between points in time. And the points in time and space are an abstraction by us. They're not ontological, they're epistemological abstraction. Go to Leibniz and you can see that. He already writes that. And then I don't need to say that your Chinese philosophy, Zhangzi and others know this already much earlier. So here I provide you the beautiful quote by Nikola Tesla. Highly recommended, actually. Go into Wikipedia and read about Tesla. Very interesting guy. Really reminds you of Elon Musk. And what we pinned down in this paper, this idea of the common currency, and that is related, if it's temporal spatial dynamics, then of course we may need a novel neuroscience, a broader framework of what I call spatial temporal neuroscience. So, what do I mean by time and space? So what, particularly in the Anglo-American world, and I think there's real cultural differences, meant by time and space is time and space in terms of discrete points. And then you have secondarily, you have relationship between these points. And that's why time and space is often, in current neuroscience, often considered with the neural correlates of the perception and cognition of time and space. And you see this as a special issue, 2016 TINS, about time and space. And it's really about discrete points in time and space. How we perceive time and space in terms of discrete points in time. Buzaki himself is also very ambivalent. He had a paper with Linus in Science, 2017-18. And you can really see it's still a very focus on discrete points in time. That's not what I mean. What I mean by time, by points in time and space, by time and space is really the construction, the relation between the point and the points then ultimately are an abstraction. And here I show you typical, and I will come back to that a lot throughout my talk. So here obviously is the brain, and you see a time series, and this time series, here's the black stuff, looks very arbitrary. However, there's a certain pattern in this. There's a structure. And you see in the background, I try to explicate that structure. Yeah, and that's what your brain spontaneous activity continuously does. Yeah, it's continuously constructing structures, relationship between different points in time and space. And importantly, you can measure these relationships. So for that, I strongly go into physics and engineering, and you will see some of the measures which we apply. So it all sounds very philosophical and abstract, but you can put some very concrete empirical flesh to the bones. And as I said, this is a starting research project. I show you some data on that. So time and space, let's be a little bit more concrete. Everybody of you who works in neuroscience knows this, nothing special here. You have this time series, you can deconstruct it, you can do a Hilbert transform or Welch transforms or other transform, and ultimately you have fluctuations of your neuronal activity in different frequencies, and you can see here, for instance, different fluctuations in different frequency ranges, very fast, gamma more than faster than 40 hertz, beta 13 to 30 hertz, alpha 8 to 30, and so on. And what is important, I want to particularly focus your attention on this one here, that the infraslow fluctuations, these are this long cycle durations, around 100 seconds, if not longer, 0.001 hertz, and that you can measure in fMRI, EEG, MEG, you can measure these faster frequencies. So, and what is important, that these frequencies have different degrees of power. So these guys here, the gamma, has much less power than these guys here, the big infraslow waves. Now, I don't need to tell you, Taiwan, you always go to the seaside, it's always very close. You see big waves, which are very powerful, last for a long time, and slow waves, but extremely powerful. That's the kind of waves you want as a surfer. And then you see a lot of small waves where you're not afraid that they smash you on the beach. So that's here, you see my, I wish I could be at the seaside now. You see slow, powerful waves, fast waves, typical, right? And that's exactly the same in the brain. Yeah, so, and that, this relationship between the slow waves power and the fast waves power is what you call here you see the frequency, here you see the power, and this is what we call scale-free distribution. Yeah, so there's a certain structure of your power spectrum which conforms to this, and that you can measure that scale-free activity with, for instance, the power law exponent. So even if you're not into all these empirical details, but you can say, look, okay, there are different degrees of power, slow, fast, and there's a certain structure in that relationship. And that structure, you will see, has major implications for mental features. And it's known that the brain has this kind of scale-free activity, like actually many other systems in nature. Scale-free activity, I will come back to that, is ubiquitous in nature. So, how will I go on? So basically, what is the common currency between neuronal activity and mental features? First step, you need to show something which is shared, and that's exactly what I mean by time and space here. This is basically a recapitulation of what I said earlier. Dynamics of time and space is a common currency of neuronal mental features. So, and ultimately, if you want to have a more metaphorical comparison, it's your mental features are basically like a surfer on the wave. Yeah, your wave is your continuous brain spontaneous activity, and then your mental features sort of are part of that and surf on the wave. And the better you align to the surfing of the wave, of course, the better to the wave's dynamic, the better you can surf. So now let me give you one example, empirical example. So I show you some data which we worked on, and I come up with the self. Usually, as you all know, particularly those who work in philosophy, the self has been always considered as a higher order cognitive function. Yeah, that again goes in Western philosophy back to Descartes, and it's a pinnacle of all cognitive functions. And that has again been carried over to neuroscience. However, there are models which speak of an embodied sense of self, Sean Gallagher, for instance, and others. But ultimately, it's always a very special instance. So what do I mean when I speak of self? So I'm sure this morning you woke up and looked into the mirror and you knew, okay, it's myself. Yeah. However, that can go wrong. I had, as a psychiatrist, I've seen several patients who had the experience they were no longer themselves. They were a different person. So I met all kinds of interesting people, including Jesus, Buddha, Nefertiti, Mao, and other famous people. And interestingly, that is actually culturally dependent. So Jesus, I never met Jesus in the Asian world, but of course I met a couple of Buddhas in the Asian world. Yeah, same with these guys here. So this is an interesting thing. So we early on, some 15 years ago, I think now, published this paper on the self, and we thought, okay, different paradigms on the self where you compare, let's say you see pictures of yourself versus another person, or you see trait adjectives, so let's say Ottawa versus Taipei for me, and so on. And then you see, when you compare that, you see a lot of activity in these cortical midline regions, also a key part of what is also called the default mode network. So, and if you assume that the self is a higher order cognitive function, then you assume that that must be related to what we call in neuroscience task evoked activity. So you have certain stimuli, you induce that, and then you have this higher order cognition. However, what we observed, that there's a strong overlap between self-related activity and your continuous resting state activity, the brain spontaneous activity. So you don't do any task and you see the same level of activation during this resting state as when you have, when you see your own picture. So meaning your own picture doesn't change the activity of these regions. So we said, this is crazy. How can this be? In the resting state, there cannot be a sense of self because there's no particular stimuli. So that's what we coined then as rest-self overlap. And that raised sort of the question, yeah, which are the features in the spontaneous activity that encode and process the information about the self? Yeah? As I said, you don't see yourself, you don't hear your name, nothing, but still there seems to be some self-specific information already encoded in your resting state. This cannot be cognition because you don't have any task. So what must the features be in the resting state that could encode the information about the self? So, and that led us, this is a study 2016 published by Zirui Wang in my group. So here we did, and remember I told you about the scale-free activity. So here you see this, here you see again these cortical midline structures. Here you see the frequency. Here you see the power. Yeah, and you see the slower the frequency, the higher the power. This is fMRI, so we're at the 0.01 to 1. And the slower the faster the frequency, the lower the power. You see that typically what you call a scale-free activity, and this you can measure with the power law exponent. But however, what you also see, you see that each of these lines is one subject. And you see a huge difference between the different subjects. Yeah, so the lines are different. And you also see somewhat differences between these two regions in the brain. So the regions in the brain seem to have their own time scales. We call it intrinsic neural time scales. And you have also huge difference between subjects. And then we also applied a self-consciousness scale, psychological scale, because in resting state, you have to have the people in the resting state, so you cannot perform any task. And interestingly, that correlated highly, particularly the private self dimension of the self-consciousness scale with the degree of scale-free activity. So at the time, this was 2016, was for me a major finding. I said, maybe there is indeed this temporal dynamics, the structure of your power spectrum, described, measured by the power law exponent, predicts your degree of self-consciousness. And what is important for the empirical experts among you, We also correlated just the power of the different frequencies or the addition of the power of the different frequencies. That didn't correlate. So it was really the structure, the shape of your power spectrum, this one, whether it's steeper or less steeper. Yeah, structure, organization. Yeah. Then we did the same in EEG. This is important because of the faster frequency range of EEG from 1 to 270 hertz here. You see typical power spectrum again. We see the correlation with the self-consciousness. And here, this is a very nice picture, which the first author of that study, Anne-Marie Wolf, did. We also applied other measures of temporal structure. Here, this is a power law exponent. This is sort of the nestedness, like the Russian dolls. I will come back to that. We also applied, for the experts among you, intrinsic timescales, autocorrelation window, providing a temporal continuity. And then here, this is cross-frequency coupling, again, more for the expert modulation index. And they all correlated, predicted the self in the resting state. So that really let us say, maybe in the resting state, there's really a temporal structure, and that is strongly related to our sense of self. And we do similar investigations in consciousness, and we just published a larger paper on here the autocorrelation, these two measures in disorders of consciousness, and we see changes in them. Yeah. Now you might say, yes, Northoff, this is all in the resting state. Yeah, but how can we really know that this is relevant for behavior? Because in the resting state, you don't do anything. There's no behavior, no cognition, nothing. So how can you know? This is just correlation, what you do there with your psychological self-scale, and correlation is always weak. So you can now provide different lines of evidence. One evidence for the behavioral relevance of this is, for instance, psychiatric disorders. It's a more indirect one, but we know that in schizophrenia and, for instance, in autism, we have disorders of self. Yeah, schizophrenia, the self becomes fragmented. Yeah, they often also lose their self. In autism, the self, I don't need to tell you, it's socially isolated. So lack of contact, lack of alignment with the environment. So and what do we find? We find exactly these measures to be abnormal in these patients. So here, this is, I think there is this is an fMRI study where we find increased power law exponent. And here, the power law exponent and also the autocorrelation window does not, this is EEG, does not react to task-related activity. So the rest task difference is too small, and that correlates, and that is linked to the basic self-disturbance. So that provides some indirect evidence for the behavioral relevance of these measures of the resting state's temporal structure, yeah, like scale-free activity, autocorrelation. Here's another study which also came out just this year. So now you say, yeah, how is the scale-free activity manifest on the psychological level? So if it's really the common currency, you would expect that the temporal structure on the neuronal level is sort of transferred or carried over to the temporal structure of the psychological activity. So that would be a true common currency. And that's what we are really trying to work on now. We have several designs where we also investigate the temporal dynamics of thought just on the psychological level. So I show you what we did here. So this is a combined psychological EEG study. So here we did a self-matching paradigm by Zui, very nice paradigm actually. She's in Britain now. So she had these shapes, and you associate the shapes with either yourself, meaning here, or with another person or a stranger. Yeah, a friend or a stranger. So you have basically self, non-self, and you have to associate the shape with the name. This is a typical paradigm, and then you have to, and you learn that, and then you're presented, and then you have to decide whether this is a correct association or not. Yeah, what you learned before. And usually you have a self-bias, that meaning all those shapes which are associated with yourself, you have higher accuracy, shorter reaction time. So what we did now, because this scale-free activity, the power law exponent, is basically different time scales Yeah, it's a long-range temporal correlation between different time scales, between the different frequency ranges. So we said, yeah, maybe we put in some delays into the task, and that's exactly what we did. So we put in the delay between the shape and then the association with the person. So, and we had three different delays for 40, 120, 70, 100 milliseconds. And what was on the behavior level quite amazing, so we saw that the self effect here, for the self effect, the accuracy was still higher even for these delays. So meaning that the self effect, that you have higher accuracy for yourself, here the shapes which you associate with your own self, is still preserved even across temporal delays. Now you will say, not of this is all working memory and attention. No, because we included working memory and attention tasks as a covariate and the results didn't change. So that really seems to be maybe some dynamic effect. And then we did the same in EEG. And that's exactly what we found, that the degree of their power law exponent, here also again in these cortical midline regions, and the degree of their autocorrelation window correlated with the delay effects and on the self-efficiency, on the accuracy. Meaning the longer your autocorrelation window, so I don't know where my mouse is here, the longer the autocorrelation window, the higher your accuracy and the better you can integrate these temporal delays without losing your self-bias and your efficiency. Yeah? So that really tells you that these dynamic measures, power law exponent autocorrelation window, have maybe corresponding effects, psychological effects with respect to temporal delays. So the idea then is here that maybe spatial temporal integration really, that these different measures allow for temporally integrating different stimuli, and the longer they are, the more better they can be integrated, and the better you can cope with these delays, that are strongly related to the self. Self is about temporal continuity, temporal persistence across time in the face of different external perturbation, and that you have these different kinds of measures here, and there are many more which we apply these days, and that's a key for what is called on the cognitive level the integrative function of self. And what is important, this is not a cognitive integration, this is a dynamic integration, it's a certain spatial or temporal structure. So here I always like to show this, you all know what this is, Last Supper from Leonardo da Vinci in Milano. If you're ever there, go there, it's really amazing. And when you look at this painting, there's one amazing thing. Look, it's a 2D canvas, but you have the feeling you're in a 3D room. And when you look at all these apostles, you have the feeling this is just one snapshot. If you would come 1 millisecond later, you would have the feeling that, for instance, here, this guy would maybe bend his face to the other direction. So there is, Da Vinci created a virtual temporal dynamic in this painting. And he does it in all his paintings. Look into the Mona Lisa, you see basically the river in the back flowing basically into the picture. That makes it so live. It's unbelievable how he does it. So the guy really knew how to deal with time and space. And that, I think, what our brain does too. So, I hope that gave you one example. We have several others. You can look on our website if you want more empirical detail. What do we mean by neuroscience? So that is really, for me, a spatial temporal neuroscience. This is a reply to the comments. Let me briefly show you. So what I say, I don't deny the cognitive level, but this is just the surface level. There's a deeper level, and that is the brain dynamics. It's not just about brain function, it's the brain dynamics. And in order to understand mental feature, you need to go to this brain dynamical level. And that's, of course, temporal spatial dynamics. And what we now do, we try to develop new measures for spatial and temporal dynamics. I didn't show you the topography stuff and so on, what we're doing. And then see how these dynamical measures predict cognitive function in a little bit the way what I tried. So the function, then brain function, is not just purely cognitive, but has a deeper dynamic underpinning. And this deeper dynamic underpinning, I would argue, is key for mental features. So here, typical example, spatial-temporal neuroscience tries to make this link and tries to embed cognitive neuroscience in a larger framework. It's not that I say, forget cognitive neuroscience. No, they have a lot of virtue, fantastic results, but that model needs to be integrated within a larger model. Yeah, in a larger framework. And you see this, for instance, here. This is, of course, a cognitive neuroscience input, cognition, output relationship. So here I would say, okay, a deeper level, you have spatial temporal relationship, measured, for instance, by the scale-free activity. Then cognitive neuroscience is always focused on stimuli, content-driven, only that neuronal activity which is related to specific stimuli and contents is supposed to be real. Here I would say no. Sorry, I lose my, yeah. Here it's about organization and structure. And we're now running a lot of topographical structure, temple structure, I showed you already a little bit. Yeah. And what is also important, cognitive neuroscience always is about information. However, in extreme states, the brain might still be dynamic, but not process information. For instance, in disorders of consciousness. External stimuli are still processed, but they're not constructed and transformed into information. So meaning the brain is more than just an information processing device. That's very important. That's this larger, deeper layer. So let me illustrate that here by consciousness. This is from the North of Lammer paper. For instance, here you see here stimulus onset. This is time stimulus onset, and usually neuroscience really focuses on what is going on after stimulus onset. Yeah, you can look for the earlier period or the later period, and that's usually associated with the contents of consciousness. The virtue of predictive coding by the Friston is really that it sheds the focus a little bit on the pre-stimulus level, but in a very cognitive way. So you have a certain prediction of outcome, and then you say, okay, whether that content matches with the content presented, you see here's a discrepancy, so you have a prediction error. What the dynamic or spatial temporal approach claims, look, there's a deeper dynamic level, and ask, what are the mechanisms by means of which this predicted input, the content, the empirical prior, is generated? And we're currently running studies and doing models where we try to link the dynamic model, let's say here the pre-stimulus, let's say the autocorrelation, directly to the empirical. Yeah? And then, of course, and then you have a certain, so we look at this deeper level. Interestingly, particularly in the visual domain, and I remember one of the studies of your group also focused on the pre-stimulus activity. And I'm a big fan of that. And also particularly how the pre-stimulus activity interacts with the post-stimulus activity, because that's not linear or additive, this is non-additive. Yeah, so that non-linearity or non-additivity is key for me in the consciousness, but I don't want to go into that. But show there's a deeper level where you can link some of these measures to some of the dynamic measures. And ultimately, you have, and that's very important, that concept for me, is sort of, you have a nestedness. You have different layers of neuronal activity. Professor Chen was speaking about different temporal layers, and ultimately these are different time scales, also spatial scales, which I completely neglected. So, yeah. So you have late stimulus, early stimulus, and probably the dynamic range is each time larger. So here you see the idea of nestedness, and that will be key to the next step, and that then also links me to the COVID and the AI. So the temporal space, so far I just focus on the link from the neuronal to the mental. However, there's yet a deeper level, and that's how your brain is embedded within the environment. And I haven't worked that out. It's sort of more as much as the neuronal mental side. But the link between the brain and the environment is probably again in temporal spatial dynamic terms. When you, for instance, listen to music, you unconsciously, involuntarily, automatically, I can only emphasize that, you synchronize with the beat of the music. And you align with the music. Yeah? So you become part of the music. And the better you synchronize, the better you feel, let's say, the groove of the music. Yeah? And that's a key. And I show you some data on that again, how we said, so this is a study published 2019 by Andrea Scalabrini, one of my students in Italy, actually. He's a psychotherapist and a neuroscientist. He's a very clever guy. And so he did this. So he did a touch, the touch of a real hand, the touch of your hand with a real hand, so another animate hand, or the hand of a robot, inanimate touch. And then what he first did, he did some psychological study. So where he said, okay, how do we perceive the other hand in terms of the self? So how close is it the other hand? You don't see the other hand. It's beyond, outside your vision. And how temporally synchronized you feel the other hand to your own hand. And how spatially close you feel. So this is subjective perception of time and space itself. So interestingly, and then he did the same in fMRI, and I'll show you those data later. But first, I want to show you the difference in the subjective perception of self-relatedness, perception of time, close, synchrony with the other, and closeness between the real hand and the robot hand. And you see huge difference. The animate/real hand was perceived as much more self-related, much more synchronized in time, and much closer in space. Yeah? So that really suggests that maybe your temporal spatial dimension is a key in mediating that contact. So and then we did in fMRI. So first, I show you just the key finding here. We compared the contrast, task-evoked animate real hand versus machine hand. And you saw, interestingly here, medial prefrontal cortex activity difference in a way that was not a surprise for us. And he looked for the scale-free activity in the resting state in that region. Here you see the scale-free activity, power law exponent. And then he predicted, and that was interesting, that the degree of scale-free activity in the resting state predicted the difference between real hand, task-evoked activity during real hand versus artificial hand. Yeah, so that really suggests that your scale-free activity in the resting state shapes your task-evoked activity reaction to particular animate rather than inanimate stimuli. So that suggests that the scale-free activity might really be a link, a common currency between your environment and your brain. And here's another example. It's an earlier study where we said the temporal dynamics of the brain spontaneous activity. So here we investigated adult sub and had the early traumatic life questionnaire. CTQ is a well-known scale for early traumatic life events, like when you're bullied or your older brother always stole your food or your sister didn't give you the milk or whatever. And also more severe events. And what we showed here, I just focus here on the right again, that we see the higher your early traumatic life experience, the higher your degree of entropy, in particular here again, the ventromedial prefrontal cortex. So the more disorganized, the more irregular your neuronal activity 20 years later. So that really suggests that maybe the scale-free activity is a key factor, the temporal space dynamics in providing the link between the environment and the brain. Here, this is a paper now, the COVID thing. So this is the idea here, that really we have a neuroecological or neurosocial alignment. So your brain synchronizes with the rhythm of the environment, in the case of music. So ultimately it adapts its own stochastics to the stochastics of the environment. And we have now several experimental lines where we probe that we investigate the stochastics of music and the stochastics of the brain. Another thing you might notice, one of my students in Taiwan now who did the painting, who investigates the temple sequence, the temple structure of how people paint, because we assume that that is reflects the sense of self and the brain, and maybe we can manipulate and use it therapeutically. So, Professor Chen already mentioned the distinction between interdependent and independent self, that you perceive yourself in a more relational way, embedded in the larger environmental context, or independent. And I strongly would say that now being in the West, but I'm now, because since I cannot travel, I Zoom throughout the whole world, and always I get the the COVID updates. There's really a cultural difference in how people deal with the virus. Here it's a lot of independent self here in the Anglo-American world, even more than in Europe as far as sense. And it's just a matter of personal right whether I have to wear a mask or not. But many people don't want it. And they absolutely have no sense that there's a deeper layer upon which they stand this alignment within the world. So they really perceive themselves as more independent and don't see that their own freedom is part of the freedom, as I would see it, endowed by the other, meaning if the other doesn't wear a mask, I might get the virus. So I think the COVID paradigmatically reflects that. And this is the paper we just published here, was just accepted here, actually in a journal which has a Japanese editor, because we tried it in many Western journals and people simply didn't understand it. And I really believe there's a huge cultural differences. And I think what the COVID really goes, this layer, when suddenly our brain cannot align anymore to the environment. And that gives you a deep existential fear and anxiety. On the philosophical side, I have, for instance, Heidegger in mind. Yeah, you are thrown into the world, but now you can't connect to the world anymore. Yeah, because there is fear. There's the COVID fear that you might be infected. Yeah, and also that you can infect the other. Yeah, so your whole relatedness is put into doubt. Yeah. And ultimately, these are really, in psychoanalysis, what here is mainly about attachment. They discuss a lot about attachment, similar thing, in what I call here alignment. Yeah. And so you have sort of what we discuss in this paper, a two-layer model of the self. We have a deeper neuroecological level, which is a balance between neuronal ecological effects. And it's always a balance. You can be more on this, more on that end. It's not an all or nothing. And on the psychological level, this is sort of the second state, as we say, is more interdependent, independent. So what I want to say here, that your brain, there's a deeper layer where your brain is intrinsically neuroecological. And if you lose that relationship, then you get existential fear. We see it in psychiatry, for instance, in schizophrenia, typical example. They lose that connectedness. And we have no control over it. There's no conscious access, nothing, no voluntary. It's automatic, it's autopilot, it's purely dynamic. Yeah. And I think that's a key thing, and you see here what COVID tells us about the self. It's a deep intersubjective layer in cultural layers or brain. Let me come to the last point. So our self is not somewhere in the brain, it's not somewhere in the mind, it's deeply rooted in the world. And one, for instance, link, or as I say, common currency, could be indeed the scale freeness. Yeah, and basically that I always like to bring in this example here, the Chinese crystal ball. You see, this is a nestedness. You have different sizes, same shapes, nested in each other. This is the Russian version, which is, by the way, not as sophisticated as yours. But that's the same, and that's the same for the temple structure. Yeah. So yourself is deeply nested within the power law, within the brain. That was a Freudian lapsus. Within the brain, and the brain is nested within the body and the environment. Yeah, and it is this degree of nestedness. Yeah, that's what yourself. So in this way, yourself is just a self-similar manifestation of your relation to the world. Yeah, And that, I think here, you see, I put the COVID here, I put early traumatic life, and the link is here, the scale-free activity. Yeah, and again, we are really trying to measure that. So you say, oh, this is an abstract model, not of this is just on philosophy. No, you can measure, for instance, the degree of scale-freeness of the music. You can measure the degree of scale-freeness of the brain, and you can measure also your behavioral time series on the psychological level. And that's exactly what we try to correlate and link all these 3 time series. That's what I call spatial-temporal neuroscience. And the better they integrated these 3 time series, the ecological, the neuronal, and the psychological, the more likely you have consciousness and mental features. That's sort of the idea. That's the idea of spatial-temporal neuroscience. So here you see this is a, I added that, it's not in the presentation, guys, this is a very nice slide from a paper with which I work on, a colleague, and here you have the brain, basically they unfold in different levels. Yeah, here's a multi-scale brain pathways, here's the society, social culture, and here's the self as a glue. So your self is not neuronal, it's not inside the brain, it's not in a higher order, it's the virtual glue between you and the environment. And when you lose that, then you can lose mental features or become a patient of mine. Yeah, and I think it's a very nice. And that I would argue carries major implications for current AI. Why? Because current AI is very driven by the cognitive approach. They moved now in the recent years to the reinforcement learning, but still it's a very input-output relationship. So what they miss is really the embedding and the alignment of the agent within the environmental context. So you see this is the paper which is in preparation, and this is based on a grant we got with Carl Friston. It was Canada-UK Artificial Intelligence Initiative. He does the UK, I do the Canada part. And so this is about, and I show you a couple of things here without going into details. So the main idea, as you know, the neuroscientists all know, Carl Friston is an extremely clever guy, and he had this idea of he comes that from physics and computer science, free energy, that basically you exchange free energy, you balance the brain's energy with the environment energy, and that it needs to be in a balance. And that in turn yields active inference and predictive coding. So you have what he calls a gradient flow of minimizing free energy, and the strength of his approach, yes, this is all mathematically formalized. And when you see some of his paper, here's all the codes, what he programs you can't imagine. It's incredible. So the question, of course, is how and why is this exchange related to mental features? Yeah, so why is this ecological, alignment key for feature? That's where I would say we need the temporal spatial dynamics. So the idea of this project is that we're converging his concept of free energy with the temporal spatial dynamics. And I showed you one earlier example where I said, how is the empirical prior, the predicted input generated? Maybe it's generated by temporal mechanisms like neuronal variability or embedded within a certain autocorrelation ring. So that is the idea, and that then is related. So basically, if you want to have it more general, his approach allows very well to predict the contents of our mental life. But he can't explain the structure within which these contents are embedded. And that's why I would say you need the temporal spatial dynamic. And also the alignment to the environment. So why is that important for AI? Because this dimension is exactly missing in the current agent. The agents only look from here to cognition. Yeah, so it's in a very cognitive, now okay, it's the reinforcement learning, but still it's a very input-output driven feature. It's not yet a dynamic system. But that's what you need to have this dynamic automatic adaptation of the agents. And how to build that in. I have in my group actually one postdoc now who already built his first own robot, and we're often discussing what are the features you need to build in. So one key feature is, and I think Professor Chen mentioned that, you need to build in temporal layers with different timescales. So here I show you a paper which is in press by one of my engineering students, Mershad Golesauki. So he investigated the intrinsic neural timescales via the autocorrelation. And you see here, there's a certain topographical structure to these autocorrelation windows, meaning certain regions have shorter timescales, and interestingly, particularly those regions for sensory direct input and output processing. Motor cortex and sensory cortices have shorter timescales. Why? Because they need to react to continuously changing input. Probably that's an inference. Yeah. Then other regions, like here, cortical midline structures, have longer timescales. They're more slow. These guys are faster. These guys are slow. So they have longer timescales, longer autocorrelation. So you already see there's a certain temporal structure, temporal spatial structure. There's a certain topography of your intrinsic timescales. Yeah? And that's probably you have meaning different temporal layers, different timescale. And that is probably key what you need to build into your artificial agents to make them more dynamic and, as we say in the title of this paper, more adaptive. So here I already said that why is this important? Because we assume that these different timescales in the brain are key in matching your brain activity with the timescales in the environment. So philosophically speaking, this is a very important point I make here. I do say that there's a stochastically based matching between the temporal spatial structure in your brain and the one in the environment. So that means it is matching, but not representation. Yeah, there is no representation in your brain. External inputs are not represented. They are matched with your brain. That's why you have all this discrepancy. And if the matching process doesn't properly work, if your spontaneous activity, spatial temporal structure is completely different than in the environment, then you misperceive. Yeah, then you have a high prediction error, as Friston would say. Yeah, here, another very recent paper of ours, done by an Italian student, Federico Sirio, who's actually a new philosopher. He came as a philosopher to my group and then left as a neuroscientist. So he learned all that, and now he just published his first paper. He's still doing philosophy. So he investigated these timescales in consciousness. And I think, yeah, I have the findings here. So he showed that when you have sleep, your autocorrelation window gets longer and longer because your slower frequency gets stronger and stronger, and your faster frequency gets weaker and weaker. So you see a abnormal prolongation of your autocorrelation window in the different sleep stages, and you see the same in anesthetic stages, here sevoflurane, ketamine. And then we did also the same for the power law exponent, same thing. However, so these are disturbances where you have a disturbance in your input processing, your stochastic matching. When I speak of input, it's not, your stochastic matching doesn't work anymore. You have no alignment anymore to the environment, conceptually speaking. Whereas in motor conditions, so here I investigated, excuse me, patients with locked-in syndrome and ALS, amyotrophic lateral sclerosis, pure motor conditions, people cannot move, but they still have consciousness. Their input processing is still preserved. They cannot produce an output. They have no motor action, but they can still have the input processing, the stochastic matching, and you saw normal timescales. So that sort of now led us to the idea that these timescales, the intrinsic timescales of the brain, are key for processing the temporal structure of the different inputs from the environment. So here, and that's again now you see you need to build into your agent timescales which correspond to the timescales of your environment. If you build in timescales, let's say, which are much faster than the timescales in the environment in your agent, then your agent will not be able to properly match with the environment. So we call this, so if there's still some relationship, but they're sort of disproportionate, the agent might be faster, and as a psychiatrist, then I would call the agent manic. And if it's completely out of touch with the time scale, then there's no complete disconnect and probably no consciousness at all. Yeah. So you see the idea of this time scale is a key thing. So now you say, yeah, this is all abstract. Please build me the agent. Exactly that's what we're trying to do now. And I tell you one thing, we try to use this, sorry, for therapeutic purposes. So here I give you a typical example, social isolation, social disconnectedness in, for instance, autism and schizophrenia, typical thing. Here, they're all connected, they can align to each other, this guy can't. Why? So now the idea is that we continuously recording, for instance, the EEG of these guys, put in the formalism of the free energy of all the active inference, which is here, and create and measure the continuous spatial temporal dynamics of this guy, then present, let's say, music, or let the person paint, what we do with the painting therapy, according to the temporal spatial dynamics of the brain, so that we slightly manipulate the music's dynamics in such a way that the brain of this guy, that his dynamics gets a little bit activated and more in tune with the dynamics of the environment. And then we hope, I know this is work in progress, obviously, brain-computer interfaces, that guy then again can sort of synchronize or align with his or her environment. Yeah, so I hope I gave a little bit understanding. Let me briefly come to my last 2-3 slides. Summary. So on a conceptual level, I said maybe we need to abandon the specialness, the assumption, the hidden assumption of the specialness of mind and exchanges by non-specialness for shared features, and look for the common currency. And actually, this is nothing new in science. Look at Darwin. Darwin suddenly say, look, there's nothing special about the human. They're just part of the wider evolution, and they share a lot with the non-human species. Yeah, same Copernicus with the Earth. The Earth is nothing special. It's just a planet, and it shows the same kind of movements like other planets. And that gave us a proper understanding of the place. So same here. That's why I link this in some of my other writing on the philosophical side with the Copernican revolution. However, what is the common currency between brain and mind? Time-space dynamics. When I speak of time-space dynamics, I do not mean discrete points in time and space, but I mean relationships between points in time and space. And you can measure that, for instance, scale-free. And these temporal spatial dynamic features are supposed to provide the basis of mental features. Like the sense of self, I showed you an example. I showed you the example of consciousness with the time scales. We have papers in preparation for mind wandering and so on. So this amounts to a spatial temporal neuroscience which tries to point out a deeper spatial temporal layer of the brain, which shares with mental features. And built on that is the more cognitive layer of the brain. Then I showed you some example about the relationship between environment and brain, that maybe the brain is in a scale-free nestedness, nested within the much larger and time scales of the environment. And the better you nest and align, the more likely you have mental features. For the COVID, I would argue that threatens this really deepest neuroecological layer. Heidegger would have said of an existential layer. Yeah? You're really thrown into work, but you can't align. So imagine something is thrown and it cannot align, and you're just there. Yeah? So that, and I mentioned the cultural differences, existential fear and anxiety. For the AI, I suggest that we need to converge the free energy and the temporal spatial dynamics to build more adaptive agents. Meaning, I discuss this a lot now these days via Zoom with my students, that we really need to build in different temporal layers. And the same goes for different spatial layers. Yeah, the brain is not just one layer thing. It's a way too simple mechanistic thing. It has multiple layers, and these multiple layers most likely conform to the temporal layers of the environment. There is empirical evidence for preservation of time scales across different species. Yeah. And last point, particularly with this recent paper on consciousness, that maybe the intrinsic neural time scales are key for the input processing. Input processing, I do not mean just a single input, like in the empiristic tradition or sensory tradition, but I mean my input is a pattern of inputs, the stochastics. Yeah. And that is, for me, key when you, for instance, want to provide proper therapy for psychotic patients like with schizophrenia or autism. And that's exactly what we're trying. We're trying to use music therapy, or I mentioned the example of painting, or we have other examples of transcranial magnetic stimulation. Yeah, and with that I come to my end. So even if you say, yeah, not of all this common currency, this is just conceptual. So even if you say it's all wrong, fine, great. I'm happy to take that. But at least it offers you some new ideas how to investigate mental features. And I hope I could convey that, and that has reverberations for not only for neuroscience, but I would say also for artificial intelligence and philosophy. Thank you very much.
Yeah, thank you for your very rich and insightful speech. And now we go to the part of discussion. And first we will welcome Professor Xie to raise his comments and questions.
Nice to meet you again, Georg. We have met several times in Yangming and on different occasions. Yeah, I remember that once you were in Yangming, I did some briefing of our work to you in my office. Some of the work we did about the transsexualism and the brain, which is something maybe I can come back to you a little bit. And I would say that I appreciate really very much the talk, your talk, for the extant elaboration of a new theory of spatial dynamics model. I call it STD model. That leads to a new discipline of spatial temporal neuroscience, STN, as you call it, for brain and mind research. I think this STN model does come in at the right time and at the right space, time and space coherence or conjugation, I would call it. In short, I think the theme, the central theme of all this effort, elaboration, tells one thing, that is neurodynamics are actually mental dynamics and also environmental world dynamics in the context of system dynamics as informed by contemporary temporal physics. If I understood correctly, I think that this is mainly based on the system dynamics in essence. Actually, can you show my slides? Yeah.
No, I see them.
Oh, okay. Originally, I made some highlights. Please go to next. I made some highlights. Yeah. Originally, I made some highlights out of your talk. I was intending to kind of make a briefing, a summary of your talk in Chinese, because I was a little bit afraid and also concerned that most of the people here in the audience, they might not have been engaged with brain imaging and kind of mapping tools. So they might have gave to appreciate and to imbibe all the contents that you presented. But I actually changed my mind after I had listened to Shuting's briefing in the beginning, and also your wonderful talk, which is overwhelmingly and immensely informative. So I changed my mind, so I will go directly to my questions, just two questions. Please see the next slides. 请看下一张哦，没关系。I'm a come back to the highlights, and I will try to do some Chinese translation of the talk you just mentioned about, particularly regarding the the nestedness or the connectedness using power law to address the self and also the world, and also extend to psychiatric problem, as well as into the modern direction of building an augmented or adaptive AI in order to facilitate the realignment between the discrepancy of the self and also the natural self. But let's come to these two questions. I wonder whether the SDN model can inform the heart problem as proposed by David Chalmers and others. We know the heart problem is the problem of why and how are the brain process that can accompany by experience for qualitative experience. I think this is very fundamental, and this is also a very big problem for all the neuroscientists and mind scientists, as well as neurophilosophers. So I wonder whether SDN, in terms of spatial temporal dynamics, can inform these fundamental and critical problems. And my second problem goes to the meditations. Actually, the question is like this: can SDN explicate the mind-engineered trait alteration of functional and structural architecture of the brain as achieved by dedicated mind training? As you mentioned, SDN proposed a transformative, intrinsic, and non-causal relationship between the neural and mental features. We may call it layers. However, the will for elaborated mind practice can actually alter the non-conscious the non-conscious and neurophysiological processes manifest in the change of synaptic density and efficiency, which in turn will lead to altered gray matter volume, thickness, and functional or effective connectivity of the neural network. So there are many, they're actually aware of the evidence that just by will for an elaborated mind practice that will actually change the temporal spatial structure, or you call it. And then this implicates there's a kind of mental neural causality instead of neural mental causality, even though that we kind of discard this kind of neural mental causality, rather we shift to neural mental transformation. But nevertheless, this kind of meditation, kind of top-down process, actually implicate a mental neural causality. So what I would like to ask is that what would be the directional impact on the MPC and the NCC, coined by you respectively? So I present this two questions to you. So while you contemplate on this, then I will try to rephrase your talk just by simple Chinese to all the friends here. So I will spend maybe 5 minutes. So it will be done in Chinese. I trust that you understand Chinese more than I do, since you are so keen to Zhuang philosophy. So I trust that you are excellent in Chinese, as conveyed by Kai Yuan. But I think it's okay. So I will just repeat all the English content that you just mentioned. 我用中文讲，因为我想他的研究里面事实上是非常的重要。但是他用的一个 approach 跟传统完全不一样。他采用的是一个 system dynamics， 应该就是说我们在讲系统的一种物理学。他特别强调这个在我们在做脑袋的研究里面，我们有别于以前我们用所谓的刺激去看脑部的反应，或者是我们用一些认知的 task， 接下来我们去看脑部什么样子的神经的回路，那么它是跟这个功能有关的。那么这些研究的方法在过去10年、20年当中，自从 brain imaging 脑部神经摄影这个技术上来了以后，基本上它是 dominate。它是占有我们在所有研究里面的一个方法学，但是呢，那个 Guild 那个 Noto 博士教授，他采用的是完全不一样的，他用的是一个 system dynamics， 就是我们把脑袋当作是一个系统，我们不去看它的这些经由刺激所引起的反应，那我们把它当作个系统。那么这个系统呢，它有一些行为上面的特征 ，in terms of time, in terms of space， 所以他就发现了。他用这种所谓的系统的特征，那么用这个时间上面，等一下我再讲，跟空间分别来看它的系统的特性，就给他发现呢，在我们的脑袋里面，在神经元的活性上面，基本上它存在了这种系统性的特征，而这种特征呢， 可以我们刚刚讲出说空间跟时间上面的结构。那空间呢，可以用所谓的功能functional connectivity 功能性的连接，或者说我们说所谓的 causal， 它中间有因果的，但这个不是它的重点。它用的是一个比较属于 complex， 就是复杂的理论，那去看这里面的一些相关。那尤其是在时间上面的结构，因为他认为我们对于这个世界的感知，对于这个外在世界，包括我们自己内部的认知经验的处理，在时间点上面不是单独独立的这个片段，而是要看每个点在时间上面，他们彼此之间所呈现的所谓它叫做 relationalism， 就是所谓的关联，就所谓的关系。那这个关系呢，我们刚刚讲，从空间上面它可以透过脑部里面哪些区域跟哪些区域，它中间形成了一个什么样子的连结，那么来烘衬出来这种认知的功能。那慢慢的大家也发现，我利用这种 functional connectivity， 我看到了这种所谓的时间上面它们是同步的，还不够，因为呢，一样的这个神经网络，它在不同的时间状态，它以不同的方式、不同的权重出现的时候，事实上它还是会跟不同的那个认知的功能有不同的结合。那么在时间上面，它特别重视的就是所谓的 nestedness， 它刚刚有特别讲。所谓的 nestedness， 我们可以讲说，在时间的这个长流上面，它有一个非常稳定横在的一个结构。那这种结构就有点像是所谓的 fractal， 就像睡形。它的意思就是说，我们在小的时间尺度或者空间尺度，它里面有基本的结构，跟我们把这个时间放长了以后，或者这个结构、这个空间把它放大了以后，基本上它们有一个一致性。那这个一致性呢，可以透过数学的方程式叫做 power law 去计算出来它的参数、它的系数。很有趣的就是说，这些利用这种系统动力学的方法，那么它可以看到脑部的这种在不管是麻醉、吃迷幻药，或者甚至于精神疾病，它都可以找出来。那么他们这种主观上面的，对不起，客观上面的系统性的研究，都可以跟它在症状学上面的表现呈现有一致上面的一些怎么讲？应该说是 qualitative， 是质上面的一个相似度，有点半定量的这种可以去怎么讲，做一种相关的哦。那特别是有关这个bipolar， 他曾经研究所谓的这个躁郁症。那躁症大家知道，当他处于躁的时候，他的脑部的思考的速度是非常的快的。而这个时候，他如果用这些 system dynamic 的方式的话，他可以看得到，就是他们的 sound entropy， 或者是他们的复杂度，基本上是比较偏高的。所以反映的这个系统的这个参数，可以代表它的意识的内涵到底是它的丰富不丰富，或者多跟寡。而反过来，对于这个所谓的忧郁症的病人，那忧郁症的病人基本上他的思考是停顿的，那么他对外在的反应也是迟钝的。那么在于他对时间的主观上面的感觉跟客观的时间上面是有落差，他会认为这个事件的发生的这个整个的脉动的过程变得非常的慢，而他也发现从脑袋里面的这个 system dynamics 这些参数，基本上他也是朝向这种比较没有这种 complexity， 比较没有 entropy 的概念在走，而不但发现在这个 brain 跟 mind 我知道哈，同时他也注意到。这样子的一种关系，这种 nestedness， 利用这种所谓的 physical law， 那么他也发现跟环境跟这个世界，基本上大家都遵循一样的这种所谓的 spatial temporal 这样子的一种规则，所以他就很有意思的，他把这种概念从自己的 brain 跟 self， 那一直到 world， 那么他以这样子的和谐一致，它叫做 alignment。那刚刚这个施廷是说是调整基本上他是希望能够说 ，OK， 我们跟世界、跟自己，那基本上是要有一个 spatial temporal 他们的一致性和谐。那这是比较符合我们东方人的思维，我们天地人，那么我们是有这样子的和谐的状态，比较符合庄子的思想。所以他特别喜欢庄子，他也特别喜欢我们开源的。OK， 所以大致上他是朝向这个概念在走。所以他的 AI 最后他事实上也是这样子的理念，他认为 AI 是在于 augment。不再发展一个所谓的 artificial general intelligence， 那么变成是说我们在发展一个人工意识，基本上要认为这个不是 AI 发展的目的。AI 发展的目的应该是让我们跟世界、跟环境、跟我们自己这个中间 alignment through 用这个客观的表征，就是所谓的 system dynamics， 那么 spatial temporal structure， 它们有它的一致性。那这个是它整个的脉络。而 COVID-19 它破坏了这个所谓的一致性，从脑袋里面，从这个跟外在人际关系的这个connectedness 跟 nestedness 基本上都破坏掉了，所以有必要把它恢复到一致性。那么这个是它整个的神经哲学的脉络。我想这是个非常非常棒的一个想法，因为基本上这个已经突破了我们在20-30年来我们在 brain science 的 research， 不管是从认知神经科学或者是从脑科学、政治科学，基本上是转了一个非常大的一个方向。那么对于 AI 未来的发展，那它也是一样的概念哦。那我想我就简单的就讲到这里。So let's go back to my slide. I think I'm a little bit over time, so I will come back to this question. So Georg, I don't think that you need to sort of address this question at the moment. I think that I will sort of, due to time constraint, I will move my microphone, hand over my microphone to the two speakers here. So.
Thank you. And we move to Professor Xie Borang. Yeah, please.
Thank you, Professor Nothoff, for your nice and interesting talk. So, rather than giving a comment, I actually would like to provide some more additional evidence for the spectrum model that we found in our lab. Next slide, please. So in Professor Nothoff's book, The Spontaneous Brain, and as well as in his talk, so he actually mentioned that he talked about the relationship between the world and brain. And he actually rejected two models in his book. One is the passive model, and the other one is the active model. So the passive model posits that neural activity is dependent, or actually entirely determined by external stimulus. And active model presumes that neural activity is entirely driven by internal spontaneous activity. And Professor Nothoff, he proposed a different model, which he calls the spectrum or interaction model. Next slide, please. So this model proposed that the brain is neither merely passive nor purely active. And he argues that stimulus-induced activity seems to be co-determined by both external stimuli and internal spontaneous activity. And in terms of evidence, he listed many experiments results showing that while there is influence of spontaneous brain activity on subsequent stimulus-induced activity, as well as influence of stimulus-induced activity on subsequent spontaneous activity. So in other words, there's a bidirectional influence from the brain to the stimulus-induced activity, as well as the other way around. And as for these evidence, actually my lab has some experiments showing that, well, there are actually quite a lot of evidence showing that there's an influence from our spontaneous brain activity on the subsequent stimulus-induced activity. For example, one of the experiments that we did in the lab is something called binocular rivalry. So binocular rivalry refers to the phenomenon that when we present two different competing information into your two different eyes, then your brain will get confused and trying to figure out the ambiguity. So usually you will perceive one item at a time, and the percept will switch every few seconds. So next slide, please. So we basically present this kind of binocular ambiguous stimulus to the subjects, and we want to know one question, which is why does the participant sometimes perceive face but sometimes perceive house? Which factors determine this phenomenon? So we did a very simple experiment. So we next slide, please. We simply present the information for half a second, and then we look for neural activity right before the stimulus presentation to see if there's any brain activity in the brain that can correlate or actually predict what you're going to perceive in this phenomenon. So next slide, please. So the question we're asking is, yeah, one more. We're asking is, does pre-trial or pre-stimulus activity in visual cortex or in the brain predict the subsequent percept or not. And the results shows that, in next slide, we found that 2 seconds before the stimulus onset, so 2 seconds before we present the stimulus, there are already brain activation difference in the fusiform phase area. So this is a phase preferred area. So we found that 2 seconds before we present the stimulus, there are already 2 different kinds of brain activation pattern. And one will lead you more likely to perceive face, and the other pattern would make you more likely to perceive house. So it seems that while before the stimulus is being presented, there's already difference in the spontaneous brain activity that can be used to predict which percept you're gonna see. Okay, and next slide. So, yeah, so the example you just saw is one example showing that pre-stimulus brain activity can bias lower level perceptual decisions like binocular rivalry. So the next question naturally would be, well, we want to know, well, how about higher level decision makings, such as evaluation or decisions involving risk. So in next slide, one of my previous students, Jaron Colas, he did experiments, which is very simple. He simply presented one abstract art. You can see in next slide. And so that's just been shown for like half a second. And the participant's job is to answer whether you like that art or not. So like or dislike. So we presented this kind of images for half a second. And every 16 seconds, we present one of this abstract art. And we have hundreds of these arts. And the task is very simple. You just say you like it or dislike it. And we discover that in next slide, that once again, 4 to 6 seconds before, there are already patterns in the brain, in medial frontal gyrus and anterior cingulate cortex, showing that these patterns can be used to predict whether the subjects are going to like or dislike the stimulus. And in next experiment as well, we discovered that even for decision-making task, this is actually a gamble task, whether you should, the subjects were asked to decide whether they're going to gamble or not. And once again, in the results, next slide, we discovered that 4 seconds before we present this gamble task, next slide, please. The subjects, one more. There are already pattern difference in the medial frontal gyrus as well as in nuclear components and caudate, showing that this pattern can be used to predict whether they're going to gamble or not. All right, next slide, please. So basically, we discovered that while pre-stimulus spontaneous brain activity can be can bias not only lower level perceptual decisions but also higher level decisions. Okay, so I guess this concludes my sharing about the additional evidence supporting supporting that actually the spontaneous brain activity can bias our percept as well as these stimulus-induced activity, which actually supports the spectrum or interactive model proposed by Dr. Nordhoff. All right, thank you very much.
Professor Xie, and now we move to Professor Wang Hua for her questions.
Thank you very much, Georg, for your wonderful presentation. And I already sent you my comments and questions, so I hope you had a chance to read it. And because even though I have some background in neuroscience, my main focus is on moral psychology and ethics. So I'm especially interested in the self-other relationship and the augmentation of human agency. So my questions will be on these 2 issues. So I definitely think that this very exciting project is leading to some kind of paradigm shift. Seems it's happening. And let's use, as Professor Xie Renjun mentioned, that this is very compatible with the Eastern way of thinking about interpersonal relationship, and basically also human-world relationship, and also mind-body relationship. So I think it's very inspiring and it's very helpful. So it's really interesting to see that you're extending the idea to not just talking about my brain, but it's surely my body, but also to the culture and others, and how the environment influence the spatial temporal model. So the first question I have is about this idea about the closeness between one and others. So one thing you mentioned is that it seems that we can perceive others similarly or closer, or there is this perceived closeness between people. And of course, one way you want to cash it out is with the spatial temporal model and how the self-others have some kind of overlap between these two models. But I'm just curious how you want to explain this similarity or overlap about models and the perceived similarity. It seems that the perceived similarity could be a kind of metaphor, but it could be something that's very literal. So especially given in culture or in how we interpret interpersonal relationship, that seems to relate to a lot of meaning and other feelings and not So I'm just curious about how you want to cash that out. And the second question is about your explanation about cultural priming and the cultural context and how that relates to interpersonal relationship. So my question, again, is about this alignment between self and other and how it is formed. It seems that it is through our perception and interaction with the others in the environment. And the question would be, can these cultural specificities and social specifics be really encoded and decoded in the spatial temporal network, or model? So it seems that the idea is that the culture and social specifics are influencing how we form the model in a certain way and how we interpret or understand others, relate to others in this way. But I'm just curious about how you understand this more specifically. And also how long and how much interaction can a stable alignment relation be formed, and how this alignment can be manifested. So relatedly, given that one of my research interests is in the role of ritual practices play in the construction of moral knowledge and moral judgment, I noticed that there are studies done in neuroscience to show how ritual practices may facilitate collective understanding and social cooperation by generating neural reactions in the spectators of ritual practice similar to that of practitioners. So I just wonder if this can also be interpreted as due to some kind of neuroecological social alignment. And also, the question about AI, I think the idea about using AI as augmenting our human agency is very interesting. Now, one question I have is this idea about how using AI to help us align with the environment. How will our normative aspect be cashed out in this alignment idea? So, for example, the one question I have is, what if the self-other relationship permeating in the environment is actually non-ideal, or it's actually not good, not helpful, not what we want? Then aligning with the environment no longer seems to be a good idea. Then in this case, how do AI correct itself, and what resources would it have? Okay, thank you very much.
Due to the time limit, please answer these questions in 5 minutes. Yeah, Professor Noto. Yeah, I'm sorry for the limitation.
Okay. All questions in 5 minutes. Okay, good. So let me start with the. Okay, I try to be quick. Okay, the heart problem. Why and how is there consciousness? So, for me, the brain is intrinsically neuroecological. And the neuroecological is a predisposition, a necessary condition of possible consciousness. And if you have that view, then you cannot raise the question for the heart problem anymore. Because when you say, why and how does the brain generate consciousness, that would imply intrinsic neuroecological and the neural predisposition. So for me, The heart problem is a problem which is based on certain presuppositions which I think are logically feasible, conceivable, but not empirically plausible. Yeah? Meditation, very interesting case. I'm very happy that you raised this. I'm trying since many, many years to conduct a good meditation study in brain imaging. I never succeeded because you need both. You need the scanning environment and you need the right meditators. So now I worked with one student who's very interested in meditation, where we reviewed all the literature on the proficiency of meditation. The deeper you get, how are the changes in the brain? And what you see, the more proficient you get in the meditation, meaning the more experience, the more the topography and the dynamics of your brain changes. So your brain in a proficient meditator is really a different brain. I give you an example. You no longer have the negative relationship between default mode network and central executive network in proficient meditation. You have a positive relationship. You have suddenly long-range synchronization between visual cortex, sensory cortex, and default mode network. You have a much larger dynamic range. So meaning what really changed, you have a different space-time dynamics and a different topography. And that really, I was just reviewing for the year because I have to agree what did I learn this year. One things I learned this year is really topography matters for the structure and organization of your mental life. How you put the contents together into your mental life. Not each content, but the relationship between the content. That's your topography. For instance, in schizophrenia and many psychiatric disorders, you have altered topography. So we investigate now for the fMRI specialists a lot of global signal topography. We just had a paper on that in the press. Again, you have a different topography, and that means you have a different organization and structure of your mental life. Yeah? So that's really, and the same goes, of course, for the scale-free dynamics, which I showed you. I'm very happy to hear with the spectrum model that you picked that up. It's indeed very much to my heart. Goes also with the current debate about the inside-outside approach, inside-out and outside-in approach by Buzzacki and others. Very nice data. I really obviously like to see that. What I would do in your case, because as I understood, these were all fMRI studies, and I saw a very long inter-trial period there, 16 seconds, which I'm even more happy to see. What I would now do, I would try to calculate pre-stimulus and post-stimulus variability. Trial-to-trial variability, pre-stim and post-stim. We did this in one paper, Huang et al., 2017. And then you can try the relationship. So I expect that in those guys where you had a longer prediction, you have a larger post-stim reduction in the trial-to-trial variability. So this would be very interesting in the data. Basically, the idea is here is a non-additive interaction between pre-stimulus and post-stimulus. And the higher the degree of non-additivity, the more likely, the more intense your consciousness. Yeah? So I think this would be a very interesting data set. And I saw the binocular rivalry I looked up on your website. So thank you very much for it. Obviously, I'm happy about it. Third question. I had hoped that you would save me the most difficult question, the one for the normative. But no escape at the end, of course, you came back to it. And that's fair, because I read your thing. Let me start. The self-other, the perceptual similarity is a good point. So, of course, as you can imagine, I assume this is not a cognitive, purely content-driven perceptual similarity. There's a deeper thing. One of my students actually came up with a really brilliant idea to correlate the topography, the dynamic topography, the distribution of your power law exponent in your different brain regions in MEG between subjects in the resting state. So meaning the degree to which my topography resembles your topography. And that might have an impact on how similar we perceive the same environmental context, which after all is shared. Yeah? However, if your topography is very different from mine, then we perceive the same environmental context in a very different structure. So here again, it's not about specific contents, it's how you embed the contents / inputs from your environment match it with the structure, organization of your own brain. And that's topography, that's scale-free activity, and these different temporal layers. Yeah? So this is one of the most exciting things. And you saw this little example which we had. I was completely surprised by those results, the animate versus inanimate. Remember the real hand versus the artificial. I couldn't believe these findings. It's unbelievable. You make such a difference because there are stochastic differences. Yeah, you feel it. Yeah. So this is really, I think that would add to the topography. The social cultural alignment, let's say the ritual. Yeah, of course, because you share the ritual. So you all align to the same thing. Neurophysiologically, I would expect with the ritual, because it's very rhythmic. Rituals are very rhythmic as far as I understand. You have a high degree of phase synchronization in the brain. Intertrial phase coherence for the EEG people, experts. So you have a high degree of synchronization. And that synchronization is, for instance, lacking in schizophrenia. They cannot align. When you have schizophrenic patients in music therapy, they cannot come with the rhythm of the music. It's unbelievable. They're just always too late or too early. They're very imprecise. So that's why we're now trying to use music therapy, brain-computer interface guided, to provide better therapy to these people. Yeah, this is of course a high-tech EEG guided and blah, blah, blah. And I think ritual, when you go to churches, yeah, in the Western tradition, I mean, the churches, okay, they're different denomination, but it's all the same. They have all rituals, they repeat, yeah. Why? To synchronize, you align to the same, you synchronize, and then the more you synchronize, you get a feeling. You get into a groove, yeah? You're metaphorically speaking, you embed yourself into something beyond larger you. I hear the same from musicians, yeah? Yeah? So this is for me one of the most, so that's why I also speak of the brain aligns to the world. That's why I speak of world-brain relation, not brain-world relation, yeah? It's an active alignment, but you align to something larger. So this is, for me, a very important difference. Yeah, the normative, it's very, very difficult for me. Of course, when I'm completely crazy, I think I can explain it with the temporal spatial, but of course, I don't need to tell you, that's nuts. I don't really know. I mean, I'm definitely, I would argue, you know that I like the Sellers and the Dowell distinction of the logical space of reason and the logical space of nature. Logical space here understood as a methodological tool, yeah, not as a logical world. So that's of course very important because after all, I'm a natural world person / a naturalist, yeah. But let's say, give me two approximations to the question, because as you see, I'm helpless and hopeless in that question, because I simply don't know. So one question, we do this line of research, actually a former Japanese postdoctoral student of mine, Takashi Nakao, who's now back in Sapporo, he came to me and wanted to investigate self and decision making. And I said, I have no idea, why do you come to me? I don't do decision making. So it took me 2 years to understand why he was there. So finally we came, because he was really interested in the subjective preferences in decision making, self and decision making. So then he developed a whole line of research, and we continue that until now, this internally versus externally guided decision making. I tell you what it is. So when you have an external decision, let's say you go to the supermarket, and of course I'm a good German, so I buy some cheese. The same cheese is $5, and in the next supermarket, the cheese is $10. So you have a clear external criterion which cheese to take, yeah, the price difference. However, so that's externally guided decision making. When you look into the cognitive neuroscience of decision making, this is mostly basically externally guided decision making. However, now imagine the same cheese is $10 each. Or let's say you have the choice between two professions. You want to become a dentist or whatever, a surgeon or a lawyer. Everything is the same, payment, blah, blah, blah is the same. That's purely internally guided, subjective preference. Yeah. And what we see in those studies that do moral guided decision making, it is like internally guided decision making. Yeah. And actually, particularly the internally guided decision making, we had a paper last year on that, is strongly guided again by this temporal dynamics, which is very interesting. Not the externally guided, the internally guided. Yeah, it's much more dependent upon your spontaneous activity and its dynamics. So there I could imagine that what you conceptually describe as a moral decision is sort of an interaction between the internally guided decision making, the spontaneous activities dynamics, but evolutionary shaped by your context. So I would probably bring in the moral component in a strong neuroecological context here. Yeah. So if I just say it's internally guided decision making, I would fall short, and you could say, no, not at all. You miss the point, and you would be right. So you need to bring in this shaping of the time scales of the brain by the time scales of the world in almost an evolutionary context-dependent cultural sense. Yeah. And yeah, and I hope I give at least some idea. What I would make, that what I would empirically out of it, what I would make philosophically out of it is probably a naturalistic version of a logical space of time and space or something like that from McDowell, where I would trace both logical space of reason, logical space of nature, back to a commonly shared, deeper logical space now in parentheses. I think you know what, yeah. But guessing. But thanks also for all the comment and the question. I really appreciate. Yeah, and also what you sent me. Thank you.
Thank you. Thank you for the wonderful speech, and thank you also for all the discussions.
好，那我们这一场就开始，非常欢迎大家。接下来我们进入第二场。那这一场的主要的目的呢是，希望我们台湾学者之间能够对于彼此现在正在做的相关研究有一些了解。那但当然就是很快的，大家有机会介绍一下大家自己在做什么研究，然后也许彼此以后可以有更多的合作和学习的机会。那所以我们这一场呢，总共有6位发表人，然后每一位也是时间都很短，只有5分钟这样子，所以就是很精彩、很简短的发表这样子。好，那我们就请第一位发表人是黄冠明老师。黄冠明老师是中央研究院中国文哲研究所研究员，谢谢。
在座的各位老师、各位各界的朋友，大家好哈。那今天来报告这个题目，其实是很外行啦，因为我并没有真的投入跟这个脑科学方面的研究，也没有做这个脑科学哲学哈。但是我可能就是从一个比较外围的角度来谈这个问题哈。那第一个大概就是说我希望是从那个价值的这个角度来思考哈。那这个有点跳。那很快的就是谈，就是说跟价值的问题呢，跟就是说刚才其实王华老师后来涉及到这个道德判断啊等这一类的问题，会有相关哈。那最主要就是说我们现在碰到的这个新冠肺炎跟这个人工智慧的这些问题，其实背后仍然有一个不单单是认知的问题，其实是跟Notov 讲到那个存在处境。哦，就是我们对存在处境的回应的这个问题，那其中一个关键当然就是跟价值的情感的的这一类的有关哦。那有一些当然就是这里我列到的是一些很基本的，我们经常碰到的一些状况哈。那好，那所以呢就是说在这一些问题里面呢，我可能这边看还比较好一点，也视力不太好了哈。那就是说我们会碰到一些很根本的一些跟我们的个人或者是集体乃至于从物种 哦，那物种呢还涉及到我们这个生物跟非生物之间的这个问题哦，就是人工智慧的问题，其实跟这个部分有关哈。然后那个COVID-19 呢，其实就是跟那个物种跟物种之间的关系哦。那但是呢，往下放到就是各个不同的国家面对这个 COVID-19 的这个回应的方式。哦，然后不同的个人的处置方式，就是说最简单的说，要不要戴口罩，然后在一个公共空间里面，他要怎么行为等等这一类的问题哈。那所以呢，就是说，我觉得在这里的COVID-19 之后哦，就是有几个基本的问题要考虑的哈。第一个问题就是说边界的问题，我说边界的问题，这个有实质的边界跟一个就是说象征性的边界哈，比如那这里面背后的问题就是说，边界究竟是要以封闭的方式来面对，还是以开放的方式来面对？哦，那这个核心的问题就是 hospitality 的问题哈。那第二个就是说真理的问题呢，已经有点转移，就是说从那个我们是不是认识到真理，变成就是说真理它是不是在一个被塑造的过程？哦，然后呢，这个塑造的过程是不是影响了人相信真理的这样的一个问题？哦，那第三个问题就是跟这个控制生命的问题哦，就是说我们本来是要问生命是什么，但是事实上呢，接着我们还有一种控制生命哦，那控制生命当某个意义它就是说打不打疫苗哦，或者像这个莱猪的问题哦，这些其实都跟这个间接是有关的哦。那所以呢，就是说，生命到底是一个不可被控制而自己成为一个目的，还是它是可以为其他生命服务，而其他的生命的形态是可以控制另外的生命形态的问题哈。那再来就是自由跟平等的问题哦，就是这些大概是我最基本的思考。那所以呢，就是说人工智慧事实上它某种程度底下哈，就是挑战的这个人类存在的边界，然后就是跟刚才的那个第一个边界的那个问题，是有相关哈。不过因为时间的关系，我就不多说哈。那就是说也有一些是 AI 擅长的事情哦，就是是不是我们就是说往那个全能性的 AI 的这个发展，其实路途还很长哦，只剩下1分钟哈。那我直接赶快跳到我真正要谈的问题哈，就是演算的问题，这个我就不谈哈。关于 data 的问题。这个就如何收集 data， 从 data 来建立模式，然后来控制这个我们的认知等等哈等等。那这些收集到越多的data 呢，是背后事实上是跟资本是有关系的哦。所以相较于刚才那个Notov 所提到的那个 common currency 哦，事实上我觉得也可以把这个 common currency 跟capital 的问题哈，就是谁拥有这些 currency 跟谁拥有这些 capital， 事实上是有关联的哈。那这个就不多谈哦，资本主义的新形态，然后跟政治体制的重新改编哦，公共领域是否消失哦？那我们现在究竟还是在这个科技乌托邦跟反乌托邦的这一个脉络里面在思考吗？哦，这有一些问题哦。时间到了，好，最后就是在这个自由跟隐私平等的这些问题里面呢，我可能就是说第一个我要谈一下，就是说数位贱民的产生哦，就是说未来可能有些人一出生就没价值哦，因为他在没有数位能力的时候呢，他根本在被这个社会被排挤哦等等。好，那没有了吗？哦，没有最后就是说，因为人种跟人类的这个问题，就是这个是对不起，我多花1分钟哈，因为后面这边就是我列了一系列现在很被谈的一些问题，就是说人本身这个物种正在改变当中哦。那所以呢，就是说有些人会醉心于这个 technological singularity 哦，那但是在谈这个 Anthropocene 的这些问题里面呢，它会涉及到 post-humanity 或者是 transhumanity 这一类的问题哦。那这个我觉得是一个值得考虑的挑战，尤其从价值的角度来说。那最后我大概就是说，具有中国的特别是儒家的一个角度的回应的话呢，感通可以是一个方式哦，因为我们刚才讲那个connection 的问题哈，就是说或者是 matching 的问题，就是可以跟这个感通哦，事实上是可以连接。那感通有5个特征哦，就是有回应性，有这个差异性哦，然后能够在回应当中呢，面对不同的形态哦，然后做连接，然后它具有公共性，然后它也有时空的连接哦，这个某种程度都相应于那个 Noto 所提到的一些问题哦。那最后大概就是说，我们要在脆弱性里面哦去看 跟那个坚韧的这个问题哦，这个我想大概就是感通跟不通里面如何再重新连接的一个思考。对不起，我多用了1分多钟哦，谢谢。
好，谢谢黄老师。那这个大家都是会讲得很短，然后让大家意犹未尽这样子。好，那接下来我们邀请谢仁俊老师，谢仁俊老师是国立阳明大学脑科学研究所讲座教授，谢谢。
大家好，那谈我的研究其实实在是没有什么了哈。那因为我是医学背景，所以我做的研究大部分是跟临床的脑神经科学有关。这几年我们把研究的路线把它浓缩，所以就只做2个，每一样都做了7、8年。那第一个是有关我们女性的经痛，原发性经痛跟脑袋的关系。那这个的话，我觉得蛮重要，因为这个一直都被忽略了哦。那疼痛在心理上面，在哲学上面都是一个常用的一个手段，或者说常常出现的一个问题。临床上面也是。应该是病人来医院就诊最常见的一个 complaint， 他的不舒服。那很多慢性的疼痛，我们发现女性是男性的3倍。比如说这个肌筋痛症候群，所谓的公主病，或者是说所谓肠躁症，或者是这种像不明原因的下背痛，那基本上都是女性多于男性2倍到3倍。那这个原因，我们认为说是跟这个痛经，因为女性有特别的生理期有关系，所以我们这几年一直利用基因、利用脑袋跟所谓的行为学，我们在医学上面的研究就叫做 genotype， 还有 imaging and phenotype， 以及所谓的行为的 phenotype， 所以采用这3个方法，那么去探讨有关这个经痛跟脑袋中间是什么样子的一种连结跟关联。那这方面的研究我们做了蛮多的哦，那这是一项。第二项可能大家会很有兴趣的，就是我们在花很多的时间，在科技部的资源之下，那我们做了6、7年，是有关不同的艺术家，那他的脑袋是一个什么样子的一种改变，他的可塑性。所以我们长期跟台北国立艺术大学，那我们几乎跟他们的每一个所跟系，那也都邀请他们的学生来。所以这里面我们有打击乐的，有钢琴的，有这个弦乐器的，有唱歌的，有这个视觉艺术的，那还有舞蹈的。那我们想要看一看这种所谓的 long-term training， 从小才艺班一路到大学进入这个专业的 training。那么这个时候我们不探讨它的单项认知功能，我们看的是这么多年长期下来这一类特定的人。那么他的脑袋的这个结构跟他的功能，那是不是能够反映出来他的艺术培养中间所需要的这些认知或者是情绪的这些，还包括记忆，那这些的元素是不是反映出他的这一类特殊的人，那他的特征，而这种特征是可以表征出来在脑袋上面的功能跟结构，所以这个是我们已经花了非常多的时间在这里。第3个比较小一点，我们最近有在观察我刚刚提的这个 meditation， 就是禅定跟这个脑袋的关系哦。那第4个我没有做，但是我觉得很重要。那我也会鼓励我们在场的所有的朋友们一起来思考。AI 时代其实对社会的冲击蛮大的哈。刚刚冠冕兄他特别讲到数位健民，还有包括这个社会的影响等等，那这个其实都是我们非常关怀的议题。那我认为说，我们年轻的一代在面对这个 AI 的这种不确定性，对社会的造成的不确定性，还有包括未来工作的被取代性，那我们必须要对年轻的一代这时候要积极做2件事，不管从研究，然后把研究变成是教育体系里面的 program。第一个就是我们要去开发我们的创造力。那传统以来，我们对于所谓创造力 divergent thinking， 那了解divergent thinking， 或者说所谓的动物 insight， 甚至于所谓的 metacognition 或是认知，那我们有这种心理上面的了解，也用在教学。那也越来越多，我们对脑科学的研究也越来越多。但是我认为这个非常重要。如果在我们的年轻的这一代里面培养 大家的这种所谓的创造力的思维，而不是局限在我们以前的所谓的选择题、是非题那种概念。那我觉得这个是我们要培养下一代这个所谓的能力上面，让他们能够人才的培养能够有国际竞争力。我想这个在 AI 时代里面更特别重要。AI 来了以后，我们大家都会失业，包括我自己现在很多 Google 本来 Google God 的概念也都有了所以我们如何去跟 AI 共处，不是让 AI 只有 adapted to us， 我们也必须发展我们自己的 intelligence augmentation， 把它叫做 IA 这是第一点很重要。第二个就是情操情操我想是 empathy15秒钟我就结束 empathy 那我想同理心应该是有同理跟共情。第一个我知道你动作你的思维的意涵，我们叫做 theory of mind， 这是心智理论。第二个就是我必须能够需要 feeling， 我必须跟你感同身受，所以我必须要有这种所谓的感知对方处于这种比较痛苦或者说比较不安定或者说比较负面的状态的这样子的能力跟这种情愫。所以一个是培养我们的能力，一个是培养我们的情操。我觉得这两个对于 AI 世代年轻的一代很重要。虽然我们有这方面的一些实际上的研究，但是这里面都跟我们之前的研究都有关系那我会鼓励我们在座的每一位朋友们，还有包括在网络上面在 cyberspace， 那今天有参加但是没有在讲的朋友，我想这两个应该是未来我们要好好去思考的方向。谢谢。
好，谢谢谢老师。那接下来我们请郑凯元老师，国民阳明心智研究所教授。对，谢谢。
好，这个谢谢大家。那我报告一下我的一个研究的状况好，那我大概有3个主要的一个研究的主题。那第一个就是说对人的这种理性思考这样的一个特质的一个研究。那理性思考概念的使用，这大概是西方文明最基础的一个特色。那几乎所有的领域大概都是以这样的为主轴那进来进行。那不过刚从 Northrop 教授的一个研究，我们可以看到他整个研究意识跟自我。这个一般在西方的文明被认为是在理性思考还在更上的一个高位的这样的一个心理的现象事实上是可以再被重新反省实际上他认为自我跟意识要放在思考理性的基础所以这是一个很大的翻转。那这样的一个研究的一个方向大概跟我从博士论文开始做这个所谓的维根斯坦里面的这个规则依循这样的问题大概后来才我觉得得到一些相互佐证的一些情况所以总之一块就是对人的概念的使用、理性的思维的一个哲学的研究，这是第一块。那第二块就是研究自我的一个本质那自我大概是这个哲学最重要的问题那这一块也是我很有兴趣的。那第3块就是我大学念工程，后来博士念哲学那所以这个背景一直还是在那边这个当做一个baseline 这样那到阳明工作这8年这个因为这环境很自然被一群这个医学家这个像谢仁俊老师这样还有科学家包围所以很自然的就是说他们的一些关切也会变成你的这个工作的养分的一部分所以在那边也很自然在思考哲学问题的时候，会有更多的一个具体的内容进来一起思考这为什么会自己跳？那所以这个理性思考这一块就我从我博士论文写 rule following 那边就这个有很基础的一些思考一个规则到底是什么那一个规则可以引导你在还没有遇到的状况可以做事情，但是这是怎么一回事那一般你要描述一个规则，你给一些例子，那给 给的会有限，那你已经累的时候，你大概只能说以此类推，啊，那推什么这样，啊，所以那在形上学啊讲倾向，啊，玻璃有可碎性，啊，可碎性就是摔了会碎，啊，但有些玻璃啊它有可碎性，但摔了没碎啊，啊，因为这个地板可能是羽毛铺的啊，所以你得要把那些条件排除，啊，或者你就加一个说哦，在正常状况下啊会这样。啊，什么叫正常状况？哦，很模糊啊。啊，或者在科学，科学里面最重要的是定律。那定律就是最严格的啊，这个像牛顿力学啊，就是所有时间、所有的地点都有一个 pattern， 啊，有一个 regularity， 啊，那问题是很多的科学啊，包括心理学、经济学啊，里面都要加其他条件均相等啊，才会怎么样？才会有一个定律。啊，什么叫其他条件啊？均相等啊，模糊。那宪法哈，这个美国宪法第4条里面有个相当理由，哦，那警察没有一个特别的相当理由，他不得搜索人，啊，不得这个进入民宅，啊，那什么叫做相当理由等等啊？所以在这所有的这些领域，我们都可以看到，啊，看似非常严谨的这些定律式的思维，它都有很大的一些阴影在后面，啊，所以这个是我这个在哲学上很大的一个研究兴趣。那讲完之后，我时间已经没了。那自我啊，这是 Note 在做的啊，那我也非常有兴趣啊。那人格同一性啊，那这些问题都牵扯到这个我死了以后会怎么样，还会不会继续活？啊，那这些问题就是东方的哲学，这当然不只是西方人在问啊，这个只要是人都会问。那东方哲学对这问题可以有什么样的一个启发啊？这是我目前的关切。然后这个就是说科学的重新再思考、再定位啊，这个啊，刚谢仁君老师也说了，这个 Note of 这一套啊，就是说很有可能会带来一个蛮新的一个格局啊。那这一块我负责做的工作啊，在跟 Note of 过去啊接近10年的合作，就是负责让他喜欢我的最爱，就是庄子啊。那他现在变他的最爱啊。那他最新的这个就是说思想，很难在西方的科学跟哲学发表啊，这是台面下的秘密啊，因为这个学界也蛮保守的啊，所以他现在最新的研究成果啊发表的地方啊，其中一个主要地方啊是在台湾这样啊，所以如果你要看他最新的哲学思想发展，因为是他的哲学思想在引导他的科学研究。那这个你们可以看一下12月将要出版的这个中研院的《中国文哲通讯》，啊，这个啊他的一篇文章啊就在里面啊会提到啊这个为什么康德、海德格还有怀德海啊这些都是他本来的英雄，为什么最后是庄子啊变成他最后的最爱啊？那这篇 paper 大家可以在那边看到。那其他就是分子生物学还有中医，在阳明那边也有非常有趣的发展。这边因为时间已经到了，如果各位想知道，再到阳明大学我们再继续聊哈。好，谢谢。
谢谢。广告一下，那篇 North of 的文章翻成了中文，所以大家如果这个对中文读觉得比较友善的话，这个建议大家可以读。好，那接下来呢，我们请陈思婷老师，国立清华大学哲学研究所教授兼所长，谢谢。
可以变大。好，那各位来宾大家好，那我可能就简介一下这个我最近在做的一个计划了。那这个计划的话，它名称基本上叫功能性介入的这个结构性的解释，就是 structural explanations for 这个 functional intervention 哦。那这个我之所以有这个想法是这样，就是因为我背景的话，就是一直以来都学就是科学方法论的那个哲学哦。那一直对，就是说，譬如说在 A 的这个环境里面所做出来的这种研究哦，它是不是可以推到 B 的这个环境里面？譬如说，动物，就是这边讲的模式动物所做的一些实验的这个结果哦，那它可不可以外推到人类来，就是给人类的类似的这种状况一些帮忙说明这样。好，那所以我一直对这种所谓的 model extrapolation 模式外推的话有兴趣。那因为在过去3年的话，就是我跟那个清大的这个脑科学研究中心，江阳生老师他领导的那个团队的话，就是有一些合作。那他们做的这个模式动物的话，就是主要是果蝇。那他们有就这个果蝇的一些行为或就是他的行为跟他的记忆跟他的学习，他们都有一些结论出来。那我就在想说，那这个的话是不是可以对于这个人类类似的这种问题的话，会不会有一些帮忙这样？那所以我就想说，那他们那个假如当做一个研究成果，当做是在一个脉络 A 下面所得到这个结果，那对于脉络 B， 譬如说我们人，譬如说也遭遇到苦痛，遭遇到一些比较不幸的这个事情，然后可能会有一些创伤，然后这些创伤要怎么治疗的话，那模式动物的这个研究，就是他们疼痛跟记忆、疼痛跟学习之间的这种关系，是不是可以外推到人这边来使用哦？所以那这个计划的话，就是有分3个部分哦。那我刚刚讲的是倒过来讲，不过我计划上面的话的进行可能就颠倒过来。我本来是对模式外推有兴趣，然后跟这个脑科中心之后就会学习到这个模式动物的一些大脑跟行为之间的这种研究的结果。那我就在想说，他们这些可不可以应用到人的这个世界？那不过我现在颠倒过来，就是说，那我可能就先研究人的这个世界有什么问题哦。那大概是这样，就是我聚焦的大概就是 narrative therapy， 就是叙事治疗。那叙事治疗它所做的事情，就可能就是说，只要有一些认知主体，那他可能经过一些，可能遇到一些大的事情，然后他有一些创伤，那这些创伤他久久不能够去掉哦，那然后可能会影响到他日后的这种生活。那叙事治疗好像就是透过跟这个患者，不管是个人一个人对一个人，或者是团体对那个人，或者是一个团体里面互相这个叙述自己的故事，然后他好像试图想要借由把那些不好的这种记忆进行重整之后，然后想要让他这个行为主体的话，可以不要那么去聚焦在以往痛苦的这个经验。所以从这边来看的话，叙事治疗的话，它可能就是借由这个语言的这种功能性的这个介入哦，然后要达到患者疼痛减轻的这个地步哦。所以它背后的话，可能大概，所以我就想说，它之间可能有一个因果关联，就是说语言的功能性介入看起来好像能够有效在患者的脑内产生相应的结构性的这种变化。也就是说，透过语言这个介入的叙事治疗，我们可以增强患者他脑袋里面哦，就是某些神经这个网路哦，那加强他某些神经网路，那让患者脑内不容易去记得，或者是让患者脑内可以抑制某些不愉快的这种长期记忆哦，那以有效阻止不愉快的这个长期记忆参与重新建构这个疼痛的这个经验组合，然后达到这个疼痛这个负担减轻的这个目的哦。所以这个是就人来讲。那模式动物方面的话，就是它也有一方面一些这方面的这种研究，譬如说透过实验，然后透过譬如说给它闻味道，然后给它电击，然后他们之间的话就会在行为跟这个脑之间的话，这个脑的变化之间的话，好像有一些关联啊。然后这些关联的话，我就在下去想说，那可不可以应用到这个用来说明叙事治疗它底层的这个运作机制是什么？那这样的话就会 就会移到就是其实我最关心的就是说，所以刚刚的这个果蝇的这个研究的这种结果，它就是在一个脉络 A 里面所得到一个结果。那叙事治疗的这个我想要说明的叙事治疗，它底层的运行机制的话，只要是脉络 B 里面的我的一个假说。那我在想说，那是不是可以借由这个脉络 A 的果蝇的这个研究的这个结果，然后外推到来说明这个脉络 B 里边的这个叙事治疗接受叙事治疗这个人，他脑袋跟他的心理状况之间有因果关联。所以要进行这个他们的这个外推是不是可行的话，基本上面的话可能要涉及到探讨所谓的这种水平的这种探寻啊，以及这种垂直的这种探寻的这种功能。在水平探寻所讨论就是说，我们要去看说两个脉络里面，然后他们所涉及到的这种因果，这种 causal factors， 他们是不是一样？就是然后也就是他们之间就是让这个现象所成因的这种supportive condition 的话，是不是一样？那只要是一样，当然就会外推的话就会更 reliable 一点。那另外的话就是要看说这两个这个脉络里面的话，他们所使用的那个因果定律的话是不是一样？好，那只要这两个条件的话都可以符合的话，那应该这样的这种外推的话就会是成功的这种外推。好，那我目前做的事情大概是这样，跟这个脑科学有关的。好，谢谢。
好，谢谢。那接下来我们请到谢伯让老师，国立台湾大学心理学系副教授。
好，大家好，我在心理系的实验室名字叫大脑与意识实验室，所以大家应该可以猜到，我们做的基本上就是跟大脑跟意识有关嘛。那我们的主要研究主题有4个大方向，第一个是我们想要知道说，人类的意识状态在出现整体性的变化的时候，大脑发生什么事？那所谓的整体性变化，就是比方说从有意识的状态进入到无意识的状态，比方说你进入睡觉没有在做梦的时候，你就是一个无意识状态嘛。所以我们有好几个这种类型的题目在做。那其中有4个我们常见的这种这个意识的剧烈变化，包括进入睡眠的时候是一个进入睡眠无梦的时候是一个大的改变嘛。那这个我们有正在进行。那另外一个呢是比方说植物人他失去意识的时候，大脑到底发生什么事？那这个我们也有正在进行中。那还有另外2个方向呢，是我一直想要做，但是还没有机会做的。一个就是药物如何影响我们的大脑，影响我们的意识状态跟大脑。然后另外一个呢，就是刚刚谢仁俊老师提到的那个meditation， 就是你在这个 meditate 的时候产生的一些意识跟大脑状态的变化，到底是怎么一回事？那这两个研究是我以后想要做的。那说不定以后有机会可以多跟谢仁俊老师请教，看看这个 project 的可行性如何哦。好，那第2个大家的目标主要是在研究说，当我们在清醒有意识的状态下的时候，其实我们的意识内容是会不断的改变的。比方说你看到的东西在变化的时候呢，你的意识经验内容会改变。那我们想要研究的是说，当你清醒的时候，当你的意识经验的这个内容状态改变的时候，大脑发生什么事情？那我们刚刚举过一个例子，就是在双眼竞争 binocular rivalry 的情况下，我们呈现一个视觉刺激，那有时候你会看到脸，有时候你看到房子，那我们就可以去问说，当你这个意识内容的经验改变的时候，大脑发生什么事情？那我们做了蛮多一系列的研究，那除了使用双眼竞争之外，也用了各种各式各样的这种视错觉来研究到底意识状态内容改变的时候，大脑发生什么事。好，那第3个研究方向呢，主要是在研究说，我们大脑如何处理无意识的资讯。那因为我们知道说，其实我们在做决策的时候，很多讯息其实是以无意识的方式在影响我们的决策。那大脑到底是怎么处理这些无意识的资讯？那我们现在也做了蛮多的研究。那我们发现说，有时候包括许多像语言啊，甚至像包括脸孔的这个美丑，然后还包括像跨感官的一些知觉整合，其实都可以在无意识的状态下被大脑所处理。好，那第4个方向呢，主要是在回来台湾以后，因为我是去年才回到台湾，那我们就开始进行一些比较有应用方面的一些研究，包括像我们现在开始采用脑造影，就是 fMRI 方法去想要 做这个测谎，就我们希望透过脑造影来进行更精确的测谎，而不是以前像使用 EEG 啊这种或者是行为方法，那它的准确性没有那么理想，那说不定我们透过脑造影的方法能够达到更精确的测谎。那另外一些跟应用比较有关的，就是我们包括像我们扫描植物人的大脑，然后透过看看这个植物人大脑对于一些声音刺激的反应。有没有能够测量到的反应，然后透过这样方法呢，来预测，比方说植物人他的苏醒几率高不高？好，那以上就是我们实验室的4个大方向。那如果等一下有机会的话，再欢迎跟大家讨论这个细节。好，谢谢。
好，谢谢谢老师。那我用这个控制。好，那接下来我也来报告一下我最近的研究。那我是政大哲学系王华。为什么会有大脑？不管，没关系，我没有关系，我就坐在这边这样。好，我是这样，因为我的之前是在之前的学习的过程是学认知科学和伦理学。那在台湾的时候就开始去很努力的继续发掘东方思想里面的一些思想资源。那因为其实刚才 Northrop 他那个他那个发表，我们已经可以听得出来，就是文化对于人的影响是非常根深蒂固的，非常非常强烈的。那它会影响到我们对于自我的看法，它会影响到我们对于人我之间关系的看法，它会影响到我们的对于任何规范性的思考的想法。好，什么是有价值的，什么是对的，什么是应该做的，这些其实都根植于文化中的人我互动之间，这样。那所以呢，在这个东方的哲学里面，其实有非常多的资源是很待开发的，就是因为我们之前很多哲学的思考和主流的思考和经验研究的这个主流的思考都是根植于西方的文化。那但是应该是说这个华人文化或者是东方的文化里面，其实有很多很多待发掘、带来启发的可能性。那所以我一直想要做的事情呢，是在发掘先秦儒家伦理学、道德心理学和后设伦理学里面的思想资源，然后把它放在世界哲学地图之上。也就是说，我们真的提供出我们可以找到的资源，那我们有独特的一个声音可以出来，然后也许让大家来思考一下其他的可能性。好，那所以这个是我想要做的事情。然后好，那我看一下，我来控制一下。好，所以我目前研究的几个面向就是我主要在做的是先秦儒家，那我更主要在做的是荀子啊，因为这个荀子他的之前已经有非常非常多对于孔子和孟子的讨论，但是荀子的偏少这样。那其实荀子在我看来是相当符合我们当代对于世界和伦理思想的一个想象的一个非常相容的一个思想方式啊。因为其实大家应该多少有了解到，就是我们跟西方伦理学有一个很大的差异，就是在于说东方哲学在很早以前天人的关系就已经不是神人关系，它并不是一个绝对的命定结构，或者是绝对的规范结构去规范人应该是什么样子。所以当然我们可以说是有某种超越性的价值，可是它跟人之间的关系，人要怎么理解这个天和自然，这个其实在先秦里面就有很多很丰富的、很有趣的发展。所以其实一直到西方的启蒙时代以后，才出现了比较多的对于神的抗拒，对于人的理性和主体性的追求。其实在先秦就已经出现了啊，就是比较一下东西方哲学的话，其实在先秦已经出现了非常多精彩的讨论。所以我一直在做一件事情，是有几点啊，就是对于荀子的道德规范性来源的探究，对于他的后设伦理学的一些研究的对话哈。然后呢，我还有在做一个问题，就是跟休谟伦理学的一个讨论。为什么呢？因为休谟伦理学很有趣的一点是，他尝试去拒绝这个神人关系的这种绝对结构，然后他想要从人文对于人的关心 和人的主体性去建构出一个伦理学。那他在这里面的讨论里面就很关心，然后剩1分钟，好，他在这里面的讨论就很关心这个体制和伦理生活的关系。好，那这个是我在做的一件事情。那另外一件很重要的事情是理和道德情感的研究，哈，就是中国哲学里面有一个很重要的面向，就是感性面向。那这个感性面向是在尤其崇尚理性的西方哲学，尤其是启蒙以后的这个面向是很不一样的。那在中国哲学里面提到的道德知识或者是道德实践，其实都是以一种体知的方式来理解。所谓体知的方式就是 embodied knowledge， 对不对？所以它一定跟身体有关，跟脉络有关，跟意象有关，跟人我的互动有关。好，所以在这个意义上，它提供的伦理方面的思想资源是非常多，然后跟西方的资源不太一样。那刚才跟那个 Georg 的讨论呢，其实也有相当有关系啊。因为我们如果从身体、从情感、从脑这些的方式去怎么跟世界连结的方向来思考的话，也许你会对于价值有一个不同的想法哈，或者是人与其他人之间的关系会有一个不同的想法。好，所以那我的时间也差不多到了，所以那个如果等一下有机会的话，再跟大家有进一步的讨论，谢谢。
时间蛮紧凑的哈，那我们就是移动到我们这个场次的第3场次。那我们也特别邀了我们的这个4位青年才俊来这个整个让这整个动态更热络这样更有内容那 Georg 好像还醒着，那所以就是这4位我们的年轻学者就是欢迎你们用中文也好，用英文也好。那直接问Georg跟他讨论也都可以或者是针对我们今天的其他讲者都 OK。第一位是颜如玉老师，他是新哲所的阳明大学的这个所长跟副教授。
Hello, Georg. I have 2 questions for you. They're both methodological questions. So the first one is how your approach changed the way cognitive neuroscience conduct their experiment and data analysis. One example is already provided by Professor Xie Borang, the comments that they can or probably better, according to your view, to incorporate pre-test spontaneous activity into their analysis. But from your talk, I got the impression that you actually want to say something way more ambitious than that, just like not just saying, you also need to analyze scale-free brain activity. I feel like you want to do something more like groundbreaking to flick things that really have some deconstruction work there, but I didn't get that from your talk. The second question is, since that spatial temporal structure is so crucial to your framework, I wonder if it follows that it's better to collect more precise temporal brain signal from neurophysiological tool or even calcium imaging rather than brain image tools.
Okay. Yeah, thank you. Two very good questions. Let me. So, how does my approach differ? For instance, we have now a self-experiment where we have a time series with 8,000 data points, behavioral, and we analyze that time series with scale-free activity and autocorrelation window. And then we have the same paradigm in EEG, and we again will analyze scale-free activity and see how scale-free activity on the neuronal level corresponds to scale-freeness on the behavior level. That, I think, is really new. Other thing, the example you mentioned, pre-stim, I suggested neuronal variability in the analysis, pre and post-stim, and I would say that the degree of variability, particularly the degree of post-stim trial-to-trial variability reduction, is directly proportional to the degree to which the content of consciousness stands out and becomes conscious, the degree of nonlinearity. Another example, we do currently a mind-wandering study. No, it's actually submitted, where we investigated the change in the thought contents. So subjects had to give indication when my thought content changed and is it an internal or external. Then we constructed a time series out of that and put that into power spectrum and the frequency. We did this purely behavioral, also in fMRI and in EEG we're going to do that. And then you can imagine what I'm doing. Similar power spectrum of your change in thought content and your brain in the respective regions. What we saw in depressed patients, the frequency of their change in thought content was significantly slower than in the healthy subject, which makes sense, and that correlated with the symptoms and high individual prediction. I'll give you a last example, spatial topography, paper we published this year, global signal topography in fMRI. What we saw that all the non-default mode networks were way too strongly connected with the default mode network. Then the time scales, and this is now, we work on that in the peripheral regions like the occipital cortex are too slow. They're too long because they're too much connected with the slow time scales of the fMRI. What happened with the default mode network? What happens in your occipital cortex, you perceive the input as too slow. Yeah, and then everything is gray and probably it's a too strong low pass filter. Yeah, and then of course now you can imagine similar spatial relation between self, non-self, visual input, self, DMN, visual cortex on the psychological level. Yeah, so the degree to which your visual input is confounded by your own self should directly correspond to the degree of abnormally strong functional connectivity from visual cortex to DMN. So what I say, what I'm interested in the dynamics of psychological mechanism. Second question.
Georg, you have to stop.
Address.
Yes, yeah, you can. Let's move to the second commentator. Yes, 林颖彤是阳明大学心智哲学所助理教授。
Hi, Georg. I have two questions as well, and the first question is so it's always really nice to converge theories, but I would like to push you to tell us more about the difference between your theory and the competing theories. Like what may be the predictions that tell the difference between your and other theories. So that's the first question, and that is related to the second question, which is what I think is a more interesting question, and I would also like to hear some comments from other researchers here. So we have so many theories now, and theories of consciousness and self, and I'm wondering like what we should do to move forward from all these theories. So one example may be one of the example is the Templeton Foundation now has a competition to asking several labs in the world to conduct theories to tell. So the thing is that there are two theories of consciousness, and one is IIT and the other is global workspace theories, and they are having this competition to kind of show which predictions from these two theories is more correct or more convincing, and they want to use to kind of move forward by having this kind of competition. And I know that some people disagree. Like they don't think this is a good way to move on from theories. And I'm wondering what you think about it, and also what other researchers here think about it.
I suggest we collect all the questions from our young scholars. So the third commentator is 郑慧颖，他是政大哲学系助理教授。
Hi, I'm Tony Chen from NCCU. So I'll only ask one question. So one important message from your talk is don't just look for differences in structures. We should also find similarities. And we can ask what kind of similarity is relevant. And you mentioned several notions, for example, isomorphism and shared features and common currency. So my question is, there seems to be huge differences between the space of reasons and space of nature. So some people say one of them is normative, the other one is not, or one of them is teleological, the other one is not. So the question is how maybe the whole framework or some of the empirical details can answer that question in rather direct ways. Also, the phenomenal structures might be different from rational structure as well. Thank you.
And our last commentator is 简世杰，那他刚从牛津大学拿到哲学博士学位。Please.
Thank you very much for having me here today, and thanks very much for the interesting and inspiring talks from Professor Nordhoff and from the other speakers. So I also have a question that is directed toward Professor Nordhoff's talk. So my question is about the philosophical foundation of the idea of spatial temporal structure, which plays a very central role in your overall theory. So, Georg, you characterize space and time as this kind of discrete spatial temporal points and the relations between these spatial temporal points. And at one point of time in your talk, you even say that, well, space and time are quote-unquote constructions. And this reminds me of Kant's view about space and time, which is a very intellectualistic view about the nature of space and time. So on his view, space and time are forms of intuitions. So put in a rough way, we perceive things under the framework of space and time. So space and time is not so much something that is out there. It's more something that is imposed by our cognitive structure in order to make sense of the world and to organize our perceptions and consciousness in a meaningful way. So this raises a very interesting question because, well, on the one hand, your interactive model of the brain comports very well with the Kantian or the intellectualistic view about space and time. So we can say that, well, space and time is not something out there, it's something that is actively provided by our brain or by our cognitive structure. But on the other hand, your presentation today seems to suggest a more objective understanding of space and time. So the idea seems to be that, well, there's a spatial temporal structure out there in the environment. And this kind of structure provides the common currency and explains the isomorphism between this kind of neural and mental spatial temporal structure. So I'm just wondering whether you can say more about the conception of space and time that underlie your overall model here. Thank you very much.
Okay, so Georg, the time is all yours. So please limit yourself to, let's say, 10 minutes.
Yeah, I'll make it short. I try to make it short. Okay. Thanks for the good questions. Very good questions. First, the competing theories. When you read the Nordhoff-Lamme paper, you will see that I don't follow that path. I rather say a good theory is a theory that integrates the other theories and puts the previous theories into a broader framework. And you see the way I indicated that, for instance, that I say now the predictive coding theory, that the pre-stimulus, that I predict that try to predict that by what Friston calls deep temporal models and temporal dynamics. For instance, neuronal variability in the pre-stim period should predict the degree of your empirical prior, the strength of your empirical prior. Yeah. So you see, I try to give a dynamic underpinning, and that means I put predictive coding into a broader spatial temporal framework. And the same I try to do with the consciousness theory. And that's what we do in that Nordhoff-Lamme paper. that we distinguish consciousness, okay, which theory focus on which part of the activity, late post-stim, early post-stim, pre-stim, spontaneous activity, and then you suddenly say somewhat different aspects of one overall picture. And of course, the overall framework, of course, you can imagine, in my case, is of course spatial-temporal dynamics because it's so basic. Yeah. So that's the wise, and I would see that different theories. You see, look at the table 1 in that paper. You really see how we try to do this. So I'm completely against this cashing out theories against each other. Each theory has a certain kernel of truth and probably targets distinct aspects. Yeah. Second question. Yeah, is of course we already touched upon this. The logical space of reason, the logical space of nature. So the way, as I understand, McDowell understands the logical space of nature as a pure empiristic sense that in time and space I would describe that's empiricism as discrete points in time. That's the classical empiristic tradition, that's what he associates with Hume, that's the logical space of nature. I would argue that's a restricted logical space of nature, a science-based restricted logical space of nature, and both Sellars and McDowell are against equating that scientifically restricted logical space of nature with the nature as such. Yeah, so they call for a broader concept of naturalism. So now, McDowell makes a step that he says, okay, there is the first nature of man, that's the science logical base, but there's also second nature of man, that's the rationality of man. So that's when he says that the logical space of reason dense overlaps with the nature. Yeah? So, and then he basically has a parallelism of the first and second nature of man and the logical space of reason naturalized and the logical space of nature proper. And that's a dualism, parallelism of the logical spaces originally, but now he has it within the natural world itself. That's his move. And I say, look, now what do these two logical spaces may have in common? So when he dents the logical space of reason, which is originally the logical world, and the logical world is by definition atemporal and aspatial. I say not only non-temporal, aspatial. There is no time and space, period. And he needs to spatial temporalize that part of the logical space of reason that makes up for the second nature of man in the natural world. And that's where I would say that's where my spatial temporal concept comes in. Yeah, so I would probably say, look, that's a deeper link, and that links the two, and both logical space of reason and logical space of nature are abstractions. These are epistemological abstractions. Yeah? These are not ontological. If you would consider them as ontological, you make an epistemological ontological fallacy, which, for instance, Kant accused Descartes of. And he's right, and we're doing that all the time in current philosophy. It's a catastrophe. But how now develop this additional logical space of nature, this more integrative than I'm working on that, but I constantly fail, so that's why it's just all in my laptop somewhere. Yeah, and it's really a difficult thing. The last point, of course, you're absolutely right. I'm a good old German, so of course Kant shaped me. And of course, you're absolutely right, as time and space, as form, as organization, as structure. I use all those terms. I wrote a whole book in German about Kant and the brain and blah, blah, blah. However, as brilliant as Kant was, what he didn't see, and you pointed out very nicely that, I would say that you need to put Kant into ecological context. Somebody who somewhat tries to do that, and therefore then also in an ontological context. That's why Kant, for me, doesn't really transgress from his epistemological position to a truly ontological position. Yeah? And I think somebody who tries to do this is Alfred North Whitehead. Yeah, when he has this principle of reversal of Kant and that he puts Kant into a broader context. So and there's also some attempts I think it's in the German side, Gerhard Vollmer, who tried to put an evolutionary reading on Kant. And if you ecologize Kant, then suddenly you don't speak of inner form anymore. And you cannot speak of outer form anymore either, because that distinction is basically, again, just an abstraction of a deeper underlying where you don't have yet this inner-outer distinction. And that's what I would probably argue, that's where this world-brain relation and blah, blah, is right at this junction where you have a dissociation between the inner and the outer, but where it's not yet distinguished. Yeah, so that's really a deeper ontological level. Yeah, I hope that addresses it somewhat.
Yeah, I think our time is really is up. So, Georg, so can you say why you think Chinese philosophy and Zhangzi is relevant to your research?
Yeah, see, a couple of things. I mean, first you introduced me to that. And so what I can really see is that you guys have no problems of thinking that maybe the relation between time points is at least co-occurrence with the discrete time points itself. When I would say that here in Canada, they say, no, first you have the discrete time point and then you have relation. Yeah? Absolutely. And that I think you have no problems of thinking that. The other thing which was touched upon, and that's of course key for my time and spacing, that's why I say, Leibniz is a little bit in that tradition, that the discrete time points in space and time are abstractions. They're epistemological. Maybe the relations are more ontological. Of course, this is a difficult thing. The other thing, of course, what for me, it's always guiding, I mean, we talked about this metaphor of Ives death. It's there's a deeper layer where you're always already embedded within nature, in harmony with nature. I know this is a key principle of your approach, and I think that ultimately, what, for instance, the brain or ourself is about. You have to be in alignment, in harmony with nature, and that shapes the brain. So it's like an imprinting through the matching with the environment. The environmental structures imprint themselves on the brain, and you can see this. Remember this early traumatic life experience, epigenetic. You have numerous examples of that. Yeah, musicians, because they do so much music, the music imprints itself on the brain. It's not that they represent the music in the brain, but it's imprinted, it's through the matching. And I think that's your cultural tradition, Zhangzi, has a much, much stronger understanding of that than the Anglo-American world. And I can see this literally. When I go to Italy, it's already better. The more you eat, the more that is stronger. Certain things I don't need to even discuss, but here, they look at me and say, what's going on? So there's a deep cultural difference, I believe.
Okay, thank you, Georg. We are happy for your wonderful talk and all the wonderful discussion. And so officially, we have to end this session. Please join me to thank Professor Georg again. And we are very grateful to 科技部人社中心。就是给我们这样的一个平台，那举办这样的一个活动。那其实主要目的除了当然 Nordhoff 教授给我们的一些互动以外，就是我们大家就是在各个领域工作，那有一些共同的一些兴趣，那可以一起讨论。所以希望这个平台只是一个开始。那大家等一下再互相留下一些联络的方式，那之后可以继续讨论。好，那就再度谢谢各位，谢谢。
非常感谢主持人与语坛人，本次工作坊圆满结束，感谢今天所有贵宾的莅临，请您在离开会场时留意随身物品，谢谢。